मतलब वो थोड़ा
Ma'am, you are not audible.
School of Biological Sciences Development is fine. अपने कॉलेज के लिए और स्पोर्ट ऑफ चैट्स बंद करो, चैट्स क्लोज करो. 3 minutes. वो डिफरेंट टाइमिंग है ना, वर्ड के सब डिपार्टमेंट परफॉर्मेंस. स्विच आउट करो या म्यूट में कर दो.
कोहेस्ट बता दें लेकिन साउंड को ना,
हाँ कोहोस्ट बना दो उसको और अभी म्यूट रखना.
लेकिन साउंड को ही
हाँ नितिन साहब इसको कोहोस्ट बनाओ,
बना दे तो भी अपने आप को अनम्यूट कर दे.
अच्छा
मेरी कला का कॉस्ट टाइम अच्छा होगा प्लेसेस ऑन द अच्छा तो जैसे करते हैं खाली लो गाड़ी पोस्ट देखिए इसमें पासपोर्ट टैग को अच्छा हमारा वो सबको तुम्हारी करेंगे सकते हैं.
Hello, mic check. Hello, mic check. Hello, mic check. Mic check. Hello, mic check. Sheetal, please close the chats. Close the chats.
It's audible, madam.
Please mute. I request everyone to be on the music mode since we are about to start. So, good morning, everyone. This is Dr. Mamta Sharma, Organizing Secretary for the International Short-Term Training Program, which has gained its popular name as isstp-5, with a chosen topic on production and regulation of chemicals and toxins for environmental conservation. पर्यावरण संरक्षण के लिए विश्व और रसायन के उत्पादन के विनियम, ये हमारा टॉपिक है isstp-5 का. This is being held under the component 8, enhancing quality and excellence, USA 2.0 scheme, and Commissionerate and the State Project Directorate, College Education, Government of Rajasthan, India, which is being organized by Rajrishi Government Autonomous College, Alwar, which is popularly known as RRC, signing in from this newly revamped, beautiful Jubilee Hall 2, which is equipped with ultra-modern facilities such as high-tech audiovisual systems and voice-sensitive cameras and mics. I would like to inform everyone today that we are just doing a notional ceremony of inauguration, and the proper inauguration of isstp-5 will be happening on 10th December, which is the foundation day of Rajrishi College, Alwar, and proudly we will be completing 92 years. So I would request everyone to please stay tuned. We have a lot more for you in this isstp-5. We are made for goodness. We are made for love. We are made for all beautiful things that you and I know. We are made to tell the world that there are no outsiders. There are no boundaries. You all are welcome. On the behalf of our patron and principal, Professor Dr. Hukam Singh Ji, and from the organizing committee of isstp-5, I welcome you all to the inaugural session of this international short-term training program. आप सभी का isstp-5 में बहुत बहुत स्वागत है, अभिनंदन है. अतिथि देवो भव कहती है भारत की ये धरा, स्वागत करके आपका निभा रहे हैं हम परंपरा. The chairperson of today's event is our patron and principal, Dr. Hukam Singh Ji, who is presiding over the event. With a lot of gratitude and respect, we all welcome you, sir, to the isstp-5. As we always do, we start every day of every event by lamp lighting ceremony in front of Goddess Saraswati. माँ सरस्वती ज्ञान और चेतना का प्रतिनिधित्व करती है. वह वेदी माँ सरस्वती को समस्त ज्ञान, साहित्य और संगीत और कला की देवी माना जाता है. Please look the chance. माँ सरस्वती की आराधना करते हुए हम इस इंटरनेशनल सेमिनार की शुरुआत करते हैं. सूरज उतरकर धरा पर खुद दीप जला रहा है. है शार दिया, है शैल दिया, ये अलग जगाने आया है. इस नदी पर भी मंदिर पर यह नए नवल बरसाया है. भावभीनी आशीषों से हम सबका हृदय छाया. सूरज उतरकर धरा पर खुद दीप जलाने आया है.
आइए प्रोफेसर होता है.
कर कृपा माँ लेखनी पर हो अमर हुई सर्जना, पावन परस कर चित्त का कच्चर करो कर कल्पना. है अर्चना है वंदना जीवन सफर कर शार दे, पूर्ण ममता दे लुटावा हर कष्ट ले प्रसाद दे. जो शुभ करता है कल्याण करता है, आरोग्य रखता है, धन संपदा देता है और शत्रु बुद्धि का विनाश करता है. ऐसे दिल की रोशनी को मैं नमन करती हूँ, बार बार नमन करती हूँ. शुभम करोति कल्याणम आरोग्यम धन संपदा शत्रु बुद्धि विनाशाय दीप ज्योति नमोस्तुते. दीपो ज्योति परम ब्रह्मा दीपो ज्योति जनार्दन दीपो हर्तु मे पापम संगा दीप नमोस्तुते नमोस्तुते. For all the delegates who are joining from the different parts of the world, a translation in English for what I said above. In India, Ma Saraswati is known as goddess of knowledge, wisdom, and education. So we are beginning the isstp-5 by remembering her, worshipping her. Lighting ceremony is done by our patron and principal, Dr. Upendra Singh, Dr. Sudha Subwan, and Dr. Sudha. Thank you so much, everyone. आप सभी का बहुत-बहुत धन्यवाद. One of the marvelous things about the community, like we all are here as a community to protect the environment, is that it enables us to welcome and help people in a way we could have done as humans. तो कहा जाता है ना कि यूनिटी में ही शक्ति होती है. That's why you all are together as the united ones. Smile is the universal value. Now it's time to welcome our patron and principal, and who is presiding over the event, Professor Dr. Thompson. I will request Dr. Upendra Singh, Dr. Sudha Subban, and Dr. Sanjay Dargan to kindly welcome our patron and principal with flowers. Sir, आपका बहुत-बहुत स्वागत है, आपका अभिनंदन है, और हम बहुत खुश हैं, हर्षित हैं, उल्लासित हैं कि आपका आशीर्वाद हम पर बना हुआ है. हम चाहते हैं कि आपका आशीर्वाद इसी तरह से हम पर बना रहे. Thank you everyone for doing the honors, and I would like to tell all the keynote speakers and all the delegates who are present here and joining from the different parts of the world that we are very, very happy and pleased to have you all here with us in the inaugural session of isstp-5. There are two powers in the world. One is the Subo and other is the head. There is a third power in the world which is stronger than all both the powers, and that is the women. Malala Yousafzai said it so correctly. I would like to tell everyone present here that RRC community strongly believe in gender equity. And here in this ISTTP, we proudly state that women are keeping more than 50% of stake in the International Short-Term Training Program. So that's of the third power of the women. Now I will request Dr. Upendra Singh, who is working as associate professor in our college. He is the nodal officer of RUSA, plus he is the advisor to isstp-5 to welcome for the welcome address. And I will request him, Dr. Upendra Singh, kindly get on the stage and welcome everyone who is present in isstp-5. Thank you so much.
Hello, everybody, and namaskar to all. आज के कार्यक्रम इंटरनेशनल शॉर्ट टर्म ट्रेनिंग प्रोग्राम isstp-5 में आप सभी का स्वागत है. सबसे पहले मैं आज के इस कार्यक्रम के अध्यक्ष हमारे सम्माननीय प्रचार महोदय जिनके बिना जिनकी मार्गदर्शन की विनती की आज्ञा की विनती की इस प्रकार का प्रोग्राम संभव नहीं है. उनका स्वागत करता हूँ, हार्दिक अभिनंदन करता हूँ. इसके पश्चात ये जो ISTP प्रोग्राम है आपका 5 नंबर का, ऐसे आगे और 5 होंगे, उनके आयोजन सचिव जिसके बिना ये प्रोग्राम भी संभव नहीं है, जो सुबह से शाम तक आपके साथ यहीं जुड़े रहेंगे लगभग आगे 7 दिनों तक. मतलब वास्तव में नहीं है, हर किसी के बस की बात नहीं है. तो उनका भी हार्दिक अभिनंदन, हार्दिक स्वागत और आभार व्यक्त करना चाहता हूँ. साथ ही हमारे साथी डॉक्टर संजय दरगान, मैडम सुधा सुब्बान, आपका हार्दिक स्वागत, वेलकम. मेरे विद्यार्थियों, आपका भी वेलकम. साथ ही इस इंटरनेशनल शॉर्ट टर्म ट्रेनिंग प्रोग्राम में भाग लेने वाले सभी प्रतिभागियों का मैं हार्दिक स्वागत करता हूँ, हार्दिक अभिनंदन करता हूँ. हमारे 7 दिन तक चलने वाले इस कार्यक्रम के सारे की नोट्स जो भी पर्सन्स हैं उनका भी मैं हार्दिक अभिनंदन और स्वागत करता हूँ। इसके पश्चात मैं स्टेट प्रोजेक्ट डायरेक्टर रूसा का आभार व्यक्त करना चाहूँगा, उनका स्वागत भी करना चाहूँगा, जिनके बिना हम इस बड़े आयोजन को करने में समर्थ होते हैं। उनका पूरा हमारे पास आशीर्वाद है, पूरा सहयोग है। जिस समय इस प्रकार के प्रोग्राम करते रहे हैं और करते रहेंगे। ममता जी नहीं यहाँ पे सारा का संभाल रखा है इस तरह के प्रोग्राम में। पुनः राजश्री महाविद्यालय परिवार की तरफ से आप सभी का स्वागत, धन्यवाद।
Thank you so much, Dr. Singh. Can you move the camera? Thank you, Dr. Singh, for your support, your guidance. Your meticulous contribution has made this isstp-5 happen. It's like bringing visual dreams into real world. Thank you so much for being what you are, and we hope you will always stay like that. Only when the last tree has died and the last river has been poisoned and the last fish has been caught, we will realize that we cannot eat well. Trust me, Dr. Raquel Carson is my hero, and this is my favorite phrase. These two things I always speak wherever I go. Wherever I stand on a forum, these two things I always speak. जब इस धरती का आखिरी ट्री कट जाएगा और आखिरी पानी की बूंद पी ली जाएगी और आखिरी मछली पकड़ ली जाएगी, उस टाइम इंसान को ये रियलाइज होगा कि हम पैसे को खा नहीं सकते। I leave the question to you. I won't describe it because you all are people who are very much aware that how we have to save the environment. It's a matter of pride and pleasure for the RRC community that we have received stupendous response from all over the world. We have nearly 1,800 registrations, 26 countries. We have 28 keynote speakers who will discuss the multidisciplinary aspects of the research trends of productions and regulation of chemicals and toxins for environmental conservation. Let me get you acquainted with the countries who are joining us in this isstp-5. Philippines, Pakistan, Nigeria, Malaysia, Iran, Bangladesh, Ethiopia, Sri Lanka, Honduras, Libya, Oman, Egypt, Canada, Singapore, United Arab Emirates, Myanmar. Myanmar is joining us for the first time. Australia, United States of America, United Kingdom, Algeria, China, Yemen, Guyana. Guyana is joining us for the first time. Kenya, Netherlands, and Ghana, and of course the host country, India. The speaker countries are Malaysia, Philippines, Tanzania, United States of America, Canada, Ethiopia, and of course the host country, India. isstp-5 is happening at Rajrishi College, Alwar, which is one of the premier colleges of the state of Rajasthan. It is co-educational, postgraduate, and a research institute, and only autonomous college in the government of Rajasthan. Presently, it is being headed by Professor Dr. Hukam Singh Ji as the PJ principal. RRC is affiliated to Rajrishi Bharatri Matsya University, which is popularly known as RRBM University, Alwar. Presently, Professor J.B. Yadav is the Vice Chancellor of RRBM University. isstp-5 is happening under the auspices of RUSA, the Rashtriya Uchtar Shiksha Abhiyan, and Dr. Upinder Singh, who is the advisor of isstp-5, is presently the nodal officer of RUSA at RRC Alwar. RRC is taking leaps and bounds under the leadership of our principal and has covered many milestones. The events which has happened under the leadership of Dr. Hukam Singh, this is December 2021. ICMESD, isstp-1, ICMSC, isstp-2, ICMA, isstp-3, ICMSDC 2022, ISODC 2022, isstp-4, and now isstp-5, and we are sitting in front of each other. My dear friends, it has been predicted by top-notch environmentalists of the world that the Third World War would be for water. It will not be for power, not be for the land, not for the arms and ammunitions, not for money, but it will be for the water, which is a basic need of life. So let's join hands and do the environmental conservation. In the later part of the 20th century, it started with the important realization that all chemicals, especially inorganic chemicals, can act as environmental pollutants depending upon the ecosystem into which the chemicals are discharged and the amount of chemical discharged. In addition, there came the realization in the current context that the emissions of inorganic compounds such as carbon dioxide, methane, and nitrous oxide to the atmosphere had either or a direct impact or even an indirect impact on the global climate, on the depletion of ozone layer. We did ISTC on the depletion of ozone layer. As a result, unparalleled efforts were made then to reduce all global emissions of all chemicals in order to maintain a green perspective to the evolution of environmental oriented thinking was followed by the formulation and passage of environmental regulations. Inorganic chemicals that are produced by various industrial processes and used in a range of products are an interesting part of modern lifestyles. Many products that have contributed to making lifestyles more comfortable, including domestic appliances, detergents, pharmaceuticals, and the personal computers, involve the use of chemicals to varying degrees. Chemicals are also an essential component of the industrial production and are used in sectors ranging from agriculture and mining to the manufacturing. Besides, the benefits of the chemical bring the economy, trade, and the employment to the rapid increase in the use and the buildup of chemicals in the environment. Also comes at price, including the loss for the flora and the fauna and any effect on including human health. Shida, someone is present, kindly check, kindly remove. Potential adverse impacts on the environmental flora and the fauna include acute poisoning and even long-term effects in humans such as cancerous growths, neurological disorders, and a very variety of birth defects. In addition, harmful chemicals can trigger eutrophication of water bodies, ozone depletion, and a threat to sensitive ecosystems and biodiversity. On this note, Endangered Species Act, which is known as ESA, was put into law to prevent extinction of endangered plants and animals and to recover these populations by preventing threat to their survival. The evolution of industrial processes and the rising consumption of inorganic chemicals have led to the rapid increase of generation of hazardous waste. These waste not only pose the risk and the hazards because their chemical properties are variable in an ecosystem. Furthermore, if advertent or inadvertent mixing is allowed to occur, the potential to contaminate large quantities of otherwise non-hazardous waste chemicals to exist. Thus, it has been recognized that the sound management of chemicals throughout their life cycle and the proper segregation, treatment and disposal of chemicals waste, that is hazardous and non-hazardous, are critical to the protection of vulnerable ecosystems. The resident floral and fauna species, including the livelihood and the human health communities. So, kindly close the chat box. Kindly close the chat box. Thank you. The greatest leader is not necessarily the one who does the great things. He is the one who gets the people to do the greatest things. Power isn't control at all. Power is strength and giving that strength to others. A leader isn't someone who forces others to make him stronger. A leader is someone willing to give his strength to others, that they may have the strength to stand on their own. This is the best how I can describe my principle. एक सफल लीडर वो होता है जो रास्ता जानता है, रास्ते पर चलता है और रास्ता दिखाता है. ऐसे लीडर हमेशा तीन चीजों का अभ्यास करते हैं: स्वयं के लिए सम्मान, दूसरों के लिए सम्मान और उनके सभी कार्यों के लिए जिम्मेदारी. सफल लीडर की ये आदत होती है कि वे लगभग हर परेशानी में संभावना ढूंढ लेते हैं, जबकि सामान्य हर संभावना में परेशानी की तलाश करते हैं। एक असल लीडर मौकों की तलाश में नहीं रहता, अपितु वो मौकों का निर्माण करता है। This is how I can best describe our head of the institution, our principal and patron, Dr. Kamsingji. There are times when we need some inspiration, uplift and motivate us. This is how RRC is blessed today and is being cherished in the great leadership of our patron and principal. He's the driving force behind this conference, and without his support, this event would have never ever happened. With lot of gratitude and respect, I would like to call upon the patron and the principal, Dr. Ukam Singh Ji, for his presidential address. 6 days is all yours. Sir, आपका बहुत स्वागत है, आपका अभिनंदन।
देशों से जुड़े लाइव इस समय लगभग 200 डेलीगेट्स 27 देशों के 1800 इस सबसे कार्यशाला में 7 नाम की नोटिस स्पीकर्स, चेयरपर्सन्स, मेरे महाविद्यालय परिवार के वरिष्ठ साथी प्रोफेसर एल.के. शर्मा जी, इस कार्यशाला की यज्ञ की उद्घाटनी विदुषी जी, आयोजन सचिव प्रोफेसर ममता शर्मा जी, महाविद्यालय के नोडल उषा नोडल विद्वान प्रोफेसर उपेंद्र जी, शिक्षक संगठन प्रमुखता के इकाई सचिव प्रोफेसर गर्गन जी और विदुषी आचार्य सुधा सुखवाल जी, तकनीकी सहायक या कहो तकनीकी विशेषज्ञ शीतल गुप्ता जी, रजनीश जी, दिलीप जी, प्रिय विद्यार्थी, आज मार्गशीर्ष शुक्ला चतुर्दशी विक्रम संवत 2089 भगवान श्री कृष्ण के जन्म नक्षत्र रोहिणी में, आज रोहिणी नक्षत्र में आयोजित और सिद्ध योग में आयोजित इस isstp-5 इंटरनेशनल शॉर्ट टर्म ट्रेनिंग प्रोग्राम 5 में दुनिया की पवित्र धरा भारत भूमि में वीर भूमि राजस्थान और राजस्थान का सिंह द्वार गढ़वाल अलवर बोस जो समग्री सम्राट अनिल भट्ट की जन्मस्थली है, और ये नाम मैं गर्व के साथ ले रहा हूं कि अनिल भट्ट सिर्फ मोहम्मद, लेकिन भक्त श्री कृष्ण का एक ऐतिहासिक तथ्य है। ऐसी धरा अलवर नवनाथोपी संप्रदाय में नवा स्थान प्राप्त महाराज महर्षि भर्तृहरि योगीराज भट्ट की तपो स्थल, पाराशर लोगों की तपो स्थल। ऐसे दुनिया की सबसे लंबी पर्वत श्रृंखला अरावली की उपत्यका में बसा अलवर स्वतंत्रता सेनानी वीर हसन खान के जन्म स्थल है। भक्त पूर्णमल की जन्म स्थल है। ऐसे संवर शहर में स्थित अलवर के हिजाई में तत्कालीन महाराज जयसिंह द्वारा उच्च शिक्षा के लिए प्रदत्त विनय दास उनका राजमहल, उसके जुबलीगार सभागार से मैं डॉक्टर हुकम से प्राचार्य राजऋषि महाविद्यालय अलवर ऑटोनॉमस महाविद्यालय अलवर मेरे स्वास्थ्य महाविद्यालय परिवार की ओर से आप सभी तमाम इस कार्यक्रम से जुड़े प्रत्यक्ष और अप्रत्यक्ष रूप से सहयोग करता आप सभी का हार्दिक अभिनंदन करता हूँ, स्वागत करता हूँ और आपके प्रति आभार है कि ये isstp-5 है। 4 isstp हम आपके सहयोग से संपन्न कर चुके हैं और ये श्रृंखला 10 पर जाकर रहेगी। आप लोगों की सहयोग के बगैर ये असंभव। आज का जो isstp है इसका विषय प्रोडक्शन एंड रेगुलेशन ऑफ केमिकल्स एंड टॉक्सिन्स फॉर एनवायरमेंटल कंजर्वेशन। मैं संस्कृत का बालक हूँ, संस्कृत का विद्यार्थी हूँ, ये विज्ञान का कॉलेज है और isstp-5 जो हम लॉन्च कर रहे थे आज आपके सामने, ये विज्ञान का विषय है। इसका अर्थ यदि मैं कहूँ इस टॉपिक का शायद ये अर्थ होगा पर्यावरण संरक्षण के लिए विश्व और रसायन की उत्पादन की विनियोग, पर्यावरण संरक्षण के लिए विश्व और रसायन के उत्पादन के नियम। मैं सामान्य सी बात आपसे करूंगा, मेरा ये विषय नहीं है और मुझसे कोई विषय अछूता भी नहीं, क्योंकि मैं उस विधा का विद्यार्थी हूं जो ये दावा करती है कि यदि आस्ति तदन्यत्र यदि न आस्ति न तत्क्वचित्। अर्थात संस्कृत का एक महाकाव्य महाभारत के लिए कहा गया है कि दुनिया में जितने विषय हैं वो महाभारत में, और जो महाभारत में नहीं है वो दुनिया में नहीं। जब मैं एक महाकाव्य के लिए विद्वान लोग ऐसा कहते हैं तो मैं तो संस्कृत वाङ्मय की बात कर, तो मैं कह सकता हूं कि मेरा ये विषय नहीं है, लेकिन ये विषय उससे अछूता भी नहीं, अछूता भी नहीं। ये ठीक वैसी बात मैं आप लोगों के सम्मुख कर रहा हूं जैसे बहस के अरविंद से जब पूछा गया था कि क्या वेदों में विज्ञान है, तो महर्षि अरविंद ने जवाब दिया था, हाँ वेदों में विज्ञान भी है, विज्ञान ही नहीं, अपितु विज्ञान भी है। तो प्रश्न वैसी बात मैं आपसे कर रहा हूं, सीधी सी बात है, विष जहर को खेलते अब बताओ, जहर भी कोई विषय है ना? अब इसको अंग्रेजी में टॉक्सिक, टॉक्सिन, और जिसमें जहर की बात की जाए वो टॉक्सिक। तो जिसमें विश्व से संबंधित बातें की जाए उसे टॉक्सिक। दूसरे शब्दों में कहूं कि जीवों के ऊपर रसायनों के प्रतिकूल प्रभावों के अध्ययन से संबंधित विधा को टॉक्सिकॉन कहा जाता है। तो सरकार ने इसको परिभाषित कर दिया। और हमारे बीच में एक टॉक्सिकोलॉजिस्ट बैठा है, प्रोफेसर ममता सर, उन्हें इस परिभाषा को सुने कि जीवों के ऊपर रसायनों के प्रतिकूल प्रभावों के अध्ययन से संबंधित विधा को विश्व विज्ञान कहा जाता है। मैंने जैसा सोचा सकता, यानी एक विधा है। अब जीवों के ऊपर रसायनों का जो प्रतिकूल प्रभाव है उसका अध्ययन उसमें किया जाए, वो विश्व विज्ञान है, उसको टॉक्सिकोलॉजी कहा जाता है। 1965 में भारत सरकार का इस तरफ ध्यान गया और लखनऊ राष्ट्रीय विश्व अनुसंधान केंद्र की स्थापना कर दी गई, लैब स्थापित की 1965 में, जो लखनऊ में है। और उसकी अब उसका हेड ऑफिस दिल्ली में है। तो भारतीय शासन 1965 से ही सावचेत है और इस विधा को भारत सरकार ने माना और उसके अध्ययन के लिए 1965 में ही लखनऊ में अनुसंधान केंद्र खोल दिया गया, जो इस पर मैं आपसे कह रहा था कि मैं संस्कृत का विद्यार्थी हूँ, 5 महाभूतों की बात आपसे मैं करूंगा। भूत तो सुने होंगे आपने, मैं महाभूतों की बात आपसे करूंगा। महाभूत 5, क्षिति जल पावक गगन समीरा, पंच तत्व है ना। आपका जो बॉडी है इसमें 5 तत्व है, पृथ्वी, जल, वायु, आकाश और अग्नि। ये 5 तत्व आप प्रकृति में देखो, पता है, पृथ्वी पर आप रहते हैं, जल आप पीते हैं, वायु आपको स्पर्श करती है, उससे आप जिंदा है ना। अग्नि से आप जिंदा है, बहुत सारे आपका खाना पीना सब उसी में पकाया जाता है, और आपके अंदर भी अग्नि, क्या नाम है उसका, उसका नाम है जठरा। क्या है? जठरा। यानी 3 तरह का भाग है जठरानल, जठरानल, वणवानल और दावानल। दावानल जंगल का भाग, जठरानल आपके पेट का, वणवानल जल का भाग, जल में भी आग लगती है, जल तो आग तो बुझाता है, नहीं, जल में भी आग, उसे सुनामी ज्वार भाटा, ठीक। तो ये जो पांचों तत्व है प्रकृति के, ये प्रकृति में मौजूद है, प्रकृति इनसे जीवित है, प्रकृति इनसे चलाएगा। लेकिन मानव अपनी सुख सुविधा के लिए भौतिक संसाधन का निर्माण करना शुरू कर दिया। मुझे यूएसए जाना है तो हमारे जहाज ट्रेवलिंग बस, ठीक है। मुझे, मैं राजस्थान में रहता हूँ, दिल्ली जाना है, कार का उपयोग करो। ट्रेन है, बस है, सरकार से। और निजी सेवा क्या है? अपना। अगर अलवर शहर से रोज 500 यात्री दिल्ली जाते हैं तो उनको 10 बसों से ले जाया लाया जा सकता है या एक ट्रेन से लाया। लेकिन मानव ऐसा करता है क्योंकि मेरे पास संसाधन है, समझ गए? आए हैं मेरे पास तो ना तो मैं पास ना मैं, तो मैं क्या करूंगा? कार अपने सुख के लिए। कार 4 लाख की भी आती है, मैं 36 लाख की खरीदूंगा। ऑडी खरीदूंगा, पता नहीं खरीदूंगा है। अब मानो अलवर से 500 में से 100 आदमी अपनी कार से दिल्ली जाते हैं रोज। ये है टॉक्सिन्स। हम सब फरमा दें, ये है विष। कैसे विष? 50 कार 100 कार अगर अलवर से दिल्ली जा रही है तो उनको बिजली पेट्रोल से, उनको डीजल से ना। अब वो पेट्रोल की डीजल से चलेंगी कारें तो 100 आदमी दिल्ली पहुंचेंगे। और मानो एक कार में 10 लीटर डीजल जलाया, उपयोग में लिया 100 कार, इधर तो कितना डीजल वेस्ट हुआ। अब डीजल वेस्ट हुआ, मैं संपन्न था, मेरे पास पैसा है, मैंने गाड़ी ऑक्युपाई किया, गाड़ी मेरी है, डीजल भी खरीद लिया। लेकिन पहले एक परेशानी वेस्ट पैदा हुई और वो था वायु प्रदूषण। मैंने मेरे शहर की हवा को, या क्या कहूँ, दिल्ली से अलवर की हवा को प्रदूषित कर दिया। और मैं मेरे जैसे तो 100 आदमी अपनी कारों से दिल्ली गए थे, उन सब ने मिलकर वायु तो अक्सर करने बात आ रही है। ये विश्व है, इसका अध्ययन विश्व अध्ययन क्या है? भाई दुनिया की कोई भी विधा, दुनिया के ज्ञान की कोई भी विधा अगर मानव के कल्याण के लिए काम करती है तो वो विधा है। टॉक्सिकोलॉजी में ये अध्ययन किया जाता है कि जो 100 कारें वहां गई उनसे कितना प्रदूषण हुआ, इसको कैसे हो। और शायद यही आविष्कार होते होते, चिंतन और मनन होते होते दुनिया सीएनजी पर, सीएनजी है ना कि भाई कम से कम प्रदूषण। अब ये मैंने प्रोफेसर डंकन कार का उदाहरण दिया, अगर मैं और संपन्न हूं, मैं हवाई जहाज का प्रयोग करूं, मुझे जयपुर से दिल्ली जाना है, मैं कार में नहीं जा रहा, मैं बस में नहीं जा रहा, मैं ट्रेन में नहीं जा रहा, मैं तो एरोप्लेन से जा रहा हूँ। और इतना संपन्न हूँ, वो एरोप्लेन में भी नहीं बैठूंगा जिसमें 300 यात्री बैठे, मैं तो ये पर्सनल निर्माण। तो आप सोचिए कि वो व्यक्ति जो उस विमान से जा, वो कितना प्रदूषण करेगा। एज आई थिंक जो मैं कार का उदाहरण दे रहा था उससे सैकड़ों गुना है। अगर 10 लीटर में अलवर से कार दिल्ली पहुंचाती है तो जयपुर से हवाई जहाज जाने में पता नहीं कितने सैकड़ों लीटर पेट्रोल लगता है, जिससे वो चलता है, पेट्रोल से ही चलता है, कितना लगेगा। और उससे उठा हुआ धुआं कितना टॉक्सिक होगा। ये अक्सर जिस विधा में किया जाए मानवता के हित के लिए, पर्यावरण संरक्षण के लिए, पर्यावरण संरक्षण कहिए चाहे मानवता का हित कहिए, बात है कि पर्यावरण अगर संरक्षित रहेगा तो मानवता सुरक्षित। पर्यावरण असंतुलित है, दूषित है, तो मानवता सुरक्षित है। ऐसे लिखा टॉक्सिकोलॉजी है। तो ऐसा अध्ययन, ये जो शब्द दिवसीय कार्यशाला है, मेरा मानना है कि इसमें जो 28 सत्र होंगे और उन 28 सत्रों में जितने भी कीनोट स्पीकर विद्वान होंगे वो पर्यावरण संतुलन के लिए कैसे ये जो विश्व बन रहा है, मानव ने अपने भौतिक संसाधनों के लिए, अपने सुख के लिए जो कुछ किया है उसको कैसे नियंत्रित किया जाए, इन विषयों पर वैज्ञानिक अपने शोध पत्र प्रस्तुत करेंगे। और जब वैज्ञानिक वादे जाएंगे तब तो जब 7 दिन तक दुनिया के 27 देशों के वैज्ञानिक और विद्वान अपने मंतव्यों को रखेंगे तो तब तो वो निष्कर्ष निकलता है और दुनिया के तमाम लोग इस श्रृंखला से, इस कार्यक्रम से जुड़े होंगे। वो उन टेक्निक से, वो उन निष्कर्षों से, वो उन अध्ययनों से, आविष्कारों से अपडेट होंगे, जागरूक होंगे। और एक जागरूक न जाने कितनों लोगों को जागरूक करेगा। तो ऐसा नहीं करना, तुम्हारा काम इससे भी तो चल सकता है यार, सको करते ये संदेश दुनिया, क्योंकि पर्यावरण संरक्षण इंडिया की प्रॉब्लम नहीं है, किसी एक देश की प्रॉब्लम नहीं है, दुनिया की। जब कोरोना आया इंडिया में, जब पर्यावरण के साथ छेड़छाड़ की जाएगी तो पर्यावरण से असंतुलित होकर जो बीमारियां पैदा होंगी वो पूरी दुनिया में। मानवता, इंसानियत किसी एक देश की नहीं होती, ये किसी एक देश की मिल्कियत नहीं है। मानवता सारी दुनिया की मिल्कियत है, इंसानियत सारी दुनिया की मिल्कियत है। और खुदा इसलिए खुदा है, भगवान इसलिए भगवान है कि वो सारी खिलकत से प्यार करता है। वो भेदभाव नहीं करता। ये इंडिया में, रशिया में, चाइनीज से ये बना है, ये भगवान नहीं सोचता, ये खुदा को सोचता। खुदा कहानी से करता है जिसको सारी खिलकत से प्यार होता है। भगवान की श्रेणी में वही खड़ा होता है जिसको सारी खिलकत से प्यार है। ऐसा सोच जब आएगा लोगों को तो करो व्यक्ति करना लक्ष्य इंसान उदार करता नाम तब धर्म साकार। इसीलिए तो भारत इसीलिए तो भारत लीड करता है, क्योंकि वो मानवता की बात करता है, वो इंसान धर्म की बात करता है, निरपेक्षता की। और जब सापेक्षता होती है वो कट्टरपन पैदा होता है, वह धर्म धर्म नहीं रह सकता है, वो संवेदनहीन हो सकता है। और जिसमें संवेदना नहीं तो कैसे इंसान है, वो कैसा धर्म है? इसलिए तो खुदा है। मैं हितों की प्रशंसा नहीं कर रहा, मैं सत्य को बुलाते जाता। और बाद में खुदा ने पंडित और मौलवियों ने धर्मों को बिगाड़, तभी तो कहा मजहब नहीं सिखाता आपस में बैर करना, वही तो धर्म नहीं। बाद के जो पंथी उन लोगों ने अपने स्वार्थ के लिए थोड़ा भगवान और परिवर्तन किया। मानवता में तो स्त्री पुरुष में कोई भेद नहीं है, लेकिन ऐसा धर्म तो स्त्री पुरुष में भेद करता है तो धर्म है। आज तो संविधान धर्म है। आज का धर्म क्या है? संविधान धर्म है, जो देश को चलाता है, जो मानवता की बात करता है, जो रंग भेद, रस्मवाद, जातिवाद, संप्रदायवाद, क्षेत्रवाद, धर्म की परिभाषा भी यही है, धार्मिक इति धर्म। जिसको धारण किया जाए उसका नाम धर्म है। ये वो लोग हैं जिन्होंने इसका और मानव को मानव से काट अलग वो धर्म। हम जो ये काम कर रहे हैं अक्सर सब अभी मेरी बैठक में विचार आया और इतना 5वां में ISTP तैयार है, लेकिन मेरे यहाँ बैठे बैठे याद आ गया, क्योंकि मैंने मेरे गुरु पर काम किया था प्रोफेसर सत्यव्रत शास्त्री पर पीढ़ी आ रहा था, तो मैंने उनके लिए लिखा था कि वो भारत के सांस्कृतिक राजदूत है, क्योंकि दुनिया के 5 देशों में उनकी पीठ स्थापित है, जिसमें कनाडा भी, जहाँ प्रोफेसर उनकी पीठ है, प्रोफेसर सत्यव्रत शास्त्री पीठ। तो जब मैंने उन पर अध्ययन किया, से मेरी बात होती थी, तब मैंने स्वयं उनके बारे में लिखा है कि वो भारत के सांस्कृतिक राजदूत थे। आज मैं ये बात इस मंच से दावे से कह रहा हूं कि हम जो ये काम कर रहे हैं आपके आशीर्वाद से, वो केवल ISTP नहीं है। तो सब आज से मैं कह रहा हूँ, हर बार कहूंगा, डॉक्टर एन के हम सांस्कृतिक राजदूत, we are cultural messenger। इन कार्यक्रमों से न केवल हम वैज्ञानिक सोच और वैज्ञानिक खोज को दुनिया के सामने ला रहे हैं, अब एक गूढ़ काम कर रहे हैं, भारत की संस्कृति को 27 और 35 देशों से हम रूबरू कर रहे हैं। और ये भारत के लिए गर्व की बात है कि हम इस छोटे से वर्ष 27 देशों में भारतीय कल्चर को भेज रहे हैं प्रोफेसर वर्धन। जब मैंने सरस्वती को का पूजन किया, आकर यहाँ बैठा, तो दरअसल प्रोफेसर मैंने आपसे कहा था इसको 27 नहीं से सरस्वती क्या है, यही तो हमारा अभ्यास है, यही तो हमारा कल्चर है। मां साहब है तो नमन करने के बगैर यह कुछ हो नहीं सकता। ये होती ऐसी है। बुद्धि के देवता गणेश की पूजा के बगैर इस देश में कुछ नाम होता है? वो आदि गणेश पहले उसका पूजन मां साहब देखा होगा, तभी के देश आगे बढ़ा है अपने मंगल। इसलिए ये कार्यक्रम न केवल बौद्धिक है, अपितु सांस्कृतिक भी, सामाजिक भी। इससे हम हमारे देश के कल्चर को विविध दुनिया के विविध देश जो हमसे वहां तक पहुंचा रहे हैं, ये एक बहुत बड़ा काम है। और जैसे आराध प्रदेश का कहा है, मैं अपील करता हूँ समस्त देश के विद्वान और संस्थाएं अपने अपने देश में ऐसे कार्यक्रम आए ताकि हम उनसे जुड़कर देख सके कि इथोपिया में क्या होता है, कनाडा में ये कार्यक्रम कैसे होता है, यूएस कैसे आयोजित करता है, चाइनीज कैसे करता है, नेपाली कैसे करता है। तब ये कल्चर का एक दूसरे से आदान प्रदान होगा और इससे होता है, इससे मानवता जिसके लिए ये सारा ताना माना गुना जा रहा है, बुन रही है सरकारें, काम नहीं कर रही है, सब मानवता के लिए। क्योंकि विकास तो इतना कर लिया कि कोई 200 कम बना के बैठा है, कोई 1000 कम बना के। समस्या है कि चल नहीं जाए, इनको रोको किससे? यूक्रेन और रशिया में जो हो रहा है, पूरी दुनिया डरी हुई है कि रूस ने अगर एटम का प्रयोग कर दिया तो क्या है ना? ये चिंता का विषय, ये मानवता को संरक्षित करने का विषय है। आपने देखा होगा, आप उसकी वैज्ञानिक लोग हैं, डॉक्टर्स जब वो प्रेस्क्राइब देखते हैं दवाइयां जो दी जाती है, तो 5 ml 10 ml बच्चे को 2 ml देनी है। क्या है ये? है मात्रा। अगर मात्रा डॉक्टर निर्धारित नहीं करे, वैज्ञानिक मात्रा निर्धारित नहीं करे, तो प्रोफेसर वही दवाई आपकी जान ले सकती है। संस्कृत पर आज खाजा हुआ है, हम तो कहते हैं अति संगत वही तो हर जगह बनते हैं, इसलिए मात्रा फिक्स की। तो ये विस्की जो मात्रा है कम से और दवाई पे लिखा है भाई, आपको मानो आप दिन में 15 लीटर आदमी को पानी पीना चाहिए, 25 पिला दो ना उसको, वैसे हो जाएगा काम, हो जाएगा ना, वो ही जहर हो गया। इसलिए मात्रा निर्धारित करना, टॉक्सिकोलॉजी करना। ठीक है, विकास भी होना जरूरी है भाई, बसें भी चलना जरूरी है, जनता इधर से उधर कैसे आएगी जाएगी, ट्रेन का भी चलना जरूरी है, हवाई जहाज का चलना भी जरूरी है। लेकिन अब सवाल ये है कि जितना ये देश होना कर रहे हैं उसको नियंत्रित कैसे, इसलिए इसका अध्ययन किया जाना जरूरी है। और ऐसी विधान टॉक्सिकोलॉजी है जिसमें इन चीजों का करके भी मात्राओं को घर किया जाता है, ताकि सारे पर्यावरण के आयाम जल भी प्रदूषित, आकाश खाना लगा, जल प्रदूषित, वायु प्रदूषित, ये जो 5 आयाम है, पृथ्वी, जल, वायु, आकाश, पृथ्वी, इनको संरक्षित करना है। अगर ये संतुलित रहेगी तो पर्यावरण रहेगा, पर्यावरण रहेगा तो कयामत संतुलित रहेगी, सुरक्षित रहेगी। यही हमारा ध्येय है और यही ध्येय संपूर्ण दुनिया का होना चाहिए। इसी के साथ मुझे लगता है कि मुझे इतना नहीं बोलना चाहिए था, है ना, लेकिन मैं बोल गया। इसलिए भी जरूरी था कि कोई ये नहीं समझे कि संस्कृत का विद्यार्थी है ना, इसलिए क्योंकि ज्ञान का ज्ञान हरि अनंत हरि कथा ज्ञान है और सफलता की सोपान कोई 10 सीढ़ी चढ़ता है, लेकिन जो 15 सीढ़ी चढ़ गया नहीं ज्ञान, 21 चढ़ा हुआ बैठा है नहीं ज्ञान, इसलिए आ रहे हैं। और मानव का देखे कि जब तक जीवित रहता है तब तक समुद्र में डूब जगह क्योंकि कहते ज्ञानात्मा वेदांत इस वेदांत कहता है ज्ञानात्मा वही ज्ञान ठीक। अब ये जो ज्ञान है जो जिसपे हम बात कर रहे हैं ये भी ज्ञान है और इस ज्ञान से आप आध्यात्म की दौर से आप चले जाओगे, कुछ करने की जरूरत अपने आप बढ़ जाए। जैसे जैसे आपकी जगह से होगी शारीरिक स्थिति होगा अपने आप सीखते जाओगे और अध्यात्म की ओर बढ़ जाओगे। ये ज्ञान तो मैं बोले इस अवसर पर तमाम सुधी जनों का, विद्वानों का, विदुषियों का, डेलीगेट्स का, प्रोफेसर साहिबानों का, डॉक्टर्स का, इंजीनियर्स का, रिसर्चर्स का आभार व्यक्त करता हूँ और अभिवादन करता हूँ पहले परिवार की ओर से कि आप सबका आशीर्वाद ताकि हम हमारे छोटे छोटे प्रयास सफल हो सके। इसी के साथ जय गुरु जय भारत। मैं मेरी भाषण को विराम देता हूँ और आज मार्च शुक्ला चतुर्दशी विक्रम संवत 2079 रोहिणी नक्षत्र और सिद्ध योग में अंतरराष्ट्रीय शॉर्ट टर्म ट्रेनिंग इस कार्यक्रम का आयोजित की आयुक्ता राजर्षि ऑटोनॉमस कॉलेज के जुबली हार सभागार से इसके प्रारंभ को से आग्रह करता हूँ। जय हिंद जय भारत।
Thank you so much, sir, for your kind words. We value the insights and the guidance you provide to all of us, and your words of encouragement keeps us motivated throughout. Your presence is very, very important to us. You showed the direction towards minimalism and sustainable development. आपको इतने सुंदर व्याख्यान के लिए बहुत बहुत धन्यवाद और आपके व्याख्यान से प्रेरित होकर क्या आज हम एक शपथ ले सकते हैं कि हम वीक में एक दिन ऐसा करें कि हम अपना ट्रांसपोर्ट ना यूज करें, क्यों ना हम किसी दोस्त के साथ जाएं, क्यों ना हम किसी पब्लिक ट्रांसपोर्ट को यूज करें, क्यों ना एक ऑटो लेके हम कॉलेज चले या साइकिल चला के कॉलेज जाएं। तो अगर ऐसा करेंगे तो शायद वो हमारा एक छोटा सा contribution होगा in the conservation of the environment. You rightly said that there are no boundaries. We all are one. We have one earth to live. Our survival is dependent on the survival of our Mother Nature. Paracelsus said it very rightly that everything is a poison. There is nothing which is not a poison. The right dose differentiates the poison and the remedy. Paracelsus कहते हैं कि आप एक व्यक्ति को किसी भी चीज से मार सकते हैं, एक चीज को किसी भी चीज से खत्म कर सकते हैं, बट एक सही डोज डिसाइड कर लीजिए कि इसे 5 ग्राम देना है कि इसे 10 ग्राम देना है. So this also said you said it very correctly, sir. The right dose differentiates the poison and the remedy. Without taking much of the time, since we are already running a bit late in our program, I would like to call upon our first keynote speaker, our inaugural keynote speaker, Dr. Nitin Sawant. Dr. Nitin Sawant is working as an assistant professor and a program director in the School of Biological Sciences and Biotechnology. Dr. Sawant has done his MSc and PhD. The topic of his PhD is ecology and conservation of pit vipers along the western ghats of Goa. He had very important positions in the past. A few of the one are, he has been the former director of Worldwide Fund for Nature India. He has been the former member secretary, Goa State Biodiversity Board, former member secretary, Goa State Council of Science and Technology, former member secretary, Goa State Innovation Council, Department of Science and Technology, former officer on special duty to Honorable Minister Srimati Arina Saldana for Science and Technology. He has many publications in national and international journals. I just glad he has many memberships of many good communities, the communities which are working for the environmental conservation. And he has many major and minor research projects going on under his supervision, and he has completed many of them as well. But what I would like to talk about is some beautiful contributions. The contributions are development of a butterfly garden for government college, funded by Directorate of Higher Education, Government of Goa, diversity of herpetofauna of Goa, Maharashtra and Karnataka, preparation of management plan for Mahadev Wildlife Sanctuary, Goa Forest Department. So right now he's working as a program director and assistant professor in Goa University, Goa. With a lot of gratitude, I would like to call upon Dr. Nitin Sawant. Dr. Sawant, the stage is all yours.
Thank you, ma'am. I hope I am audible.
Yes, we can hear you, sir. आपका बहुत-बहुत स्वागत, आपका अभिनंदन.
Thank you so much, ma'am, for it's a very important platform which you have provided me, and you are doing a fabulous job. Hello, am I audible?
Yes, sir, you're very much audible. We can see you and we can hear you.
Yeah, thank you so much. I think on behalf of my university, on my personal behalf also, I thank Professor Hukum Singh Sarji and also Professor Mamta Sharma Madam for giving me this opportunity. It is a very important platform where today we are having so many delegates across the globe. And I really enjoyed the trip in Rajasthan, ma'am. I wish to again visit you. Definitely, it is a real learning experience with so many people, right? So I really appreciate the initiative by organizing this international short-term training program on production and regulation of chemical and toxins for environmental conservation. So today, I will certainly deal with briefly because time is also very short. So I will just try to do the justice to whatever I'm going to speak. I'm going to speak in very general, not in very specific, because all the research is ongoing. So Goa being the tourist state and being a coastal state, we certainly have a lot of issues pertaining to the what you call the pollution and the pollutant and the toxins which are going into the river or the sea, and we at the coastline we completely depend on the coastal biodiversity for our day-to-day use, and we certainly look at the coast for our livelihood also, and it adds to the major economy of the state as well as across the globe rather. So if you permit me, I've already shared my presentation. I hope it is visible to all of you.
Yes, sir, very much visible. Please go ahead.
Yeah,
And we
thank
can take
you.
questions.
And let me know if the slides are changing, ma'am. Yeah, please.
Yeah,
Yeah.
sure.
So we have a lot of these.
Yeah, it's changing, it's changing, it's
Okay,
changing.
thank you, ma'am. Thank you, ma'am. So when we talk about the environmental toxicology, I think we are not supposed to blame any one individual, because we have been, developing country, and we are producing lot of, toxic material, toxic, which are, we are using day to day in the form of maybe for a production of vegetable, maybe fruits, and we are using pesticides and a lot of fertilizer, chemical fertilizer, which are rather going going into the ecosystem. So it is a great concern with effects of different chemical, physical, and biological agents of living organisms in the environment, which are very, very harmful for the whole community, including the ecology of the place. So we talk about the toxicology, what we observed in the organism due to any of these agents may be correlated with that found in the environment, and might ultimately definitely have a major impact on the human life. So Goa being also the mining state, where we have a open iron ore mining and bauxite mining, we have seen the tremendous increase of demand of the iron ore, and the whole business got shut down in 2012 because of immense. Yeah, may I continue, ma'am? Madam Sharma, may I continue, please?
Yeah, yeah, sure, sir,
Yeah,
please.
yeah. I think there is some disturbances, so I was just worried.
You just proceed.
Yeah, yeah. So there are most common sources of environmental toxicology and toxicity in the whole of environment. But Goa is really blessed with lot of greenery, lot of good suggestions, the policy decisions, which we regularly we try to monitor it. The public is very vigilant here. The people who are coming from across the globe, they are very vigilant about the Goa, and we talk about lot of these sources, different sources of environmental toxicology. We talk about the mining, we talk about the agriculture, we talk about the plastic which is generated, we are talking about the vehicular movement which is increasing in the state of Goa. It's alarming today, and still even then the government is trying their best to come out with certain policy decisions, and Goa is the only state, I would say, we have a proper pollution units, pollution certificate, which is given to the vehicles, because we have a very stringent laws in Goa for even getting the pollution certificate. So however, but there is immense increase, enhance of movement of vehicular, as well as the increase in the human population, the what you call influx of the migrant and permanent residents of the state is also putting a lot of pressure. So we have heavy metals, pesticides, and a lot of industrial effluent which are also going into the environment, into the human, which is impacting the human life. So we have toxic heavy metals in the form of mercury, which is the mode of entry, the element which through inhalation, ingestion via food, and once in a body, you and every third person in a family today, we are facing a lot of problem of cancer. Every third person in a family has a cancer, maybe a bone cancer, maybe a liver cancer, or maybe there are blood cancer. There are many cancers which are coming up in this. So Goa is a blessed with a lot of these eco-sensitive areas. But however, as I mentioned earlier, we have influx of migrant which are residing in the state, where there's a lot of pressure on the prime areas, on the hills, on the agricultural land, on the rivers, on the ocean. So if you see on the coast, there are more than 30 beaches, and which are highly economically valued beaches, which we talk about. But there is a lot of tourists which are beyond the carrying capacity, and there is a lot of illegal activities. The demand for shacks, the demand for hotels, demand for residential complexes has increased like anything, and the cost of the land has gone very high. and the Goan origin cannot even enjoy the beauty, enjoy the life in Goa. So it has become very difficult, because one side it is a Western Ghat, other side it is a coastline, and in between we have a plateau and the agricultural land and the wetland. So it has become very difficult for any developmental activity. So when we talk about the Goa, we definitely talk about the fisheries, and we our staple food is fish curry rice. We cannot do without that. So we are facing a tremendous problem nowadays, because a lot of research happening right now. I am not concluded with it, because we are still going ahead with a lot of analysis in our laboratory. We are doing on a lot of toxic analysis on these diversities, the shellfishes, and we are finding a lot of these methyl mercury. And you are well aware about the Minamata disease in Japan, which was first detected in 1956, which was discovered in the Minamata. And it has caused the release of methyl mercury in the industrial wastewater from the chemical industry, rather, and which has definitely directly or indirectly impacted these fish. And then there is also impact due to consumption of these fish on the health concerns for human who are maybe pregnant, nursing mother, and young children. So this is a very, very alarming situation. So sometimes it is going unnoticed, but we are now trying to examine even some of the fish coming from other states, like from Karwar, maybe from other states, adjoining states of Goa. They are also putting formalin in the fish, which has become a big issue just few years back. I really don't know the situation now, but we recently also tried to analyze whether the formalin is there in the fish, and we detected the formalin is still being used to preserve the fish and sell that fish to the community. So it is a alarming call how we best can sustain this biodiversity without putting any chemicals. We during olden time, in olden days, we have enjoyed these mussel, without doing any mussel farming or anything. It was available even free of cost in the nature. Anybody could go and just get it. All these are, this is Paphia malbarica, this is Misoda erosa, we have Bilorita, we have Perna viridis, we have Paphia malbarica, Paphia texta. So we have Meretrix. I'm sorry, this is species. And if you this particular Perna viridis called as a green mussel, we used to get even free of cost from the ecosystem. Today, one Perna viridis, this green mussel, costs 50 rupees one, which is very, very high for any middle class person who want to think about it. And we have been started doing this mussel culture, green mussel culture. But however, these particular species are highly impacted with the toxins. And if you see, Goa is also becoming a sort of a transportation of coal. So coal particles contaminating Mandavi River found in oyster too. The study says in 2019. So the study suspect that the river gets the mercury most likely from coal handling at Goa Marmagua port through the mercury content in oyster was found to be within permissible limit. However, consumption of these mussels are regularly happening in the state of Goa, and we eat it very regularly. So water pollution threatens Goan shellfish, and many places because of the siltation, because of the mining, lot of these diversity we have already lost. And whichever diversity is available is also contaminated with the heavy metals. So it is whether to consume or not to consume is a big challenge for the Goans, and we do not find the same taste what we were having it before when we were children. So this is one of the site, very important site. When I was a member secretary of Biodiversity Board, there was a proposal to have a marina on this area, and this was a mass breeding site of Paphia malbarica, what we call Konkani Tisro, and thousands of people would just enjoy this Tisro, enjoy this particular delicious food, and it's a very important staple food, I would say. Many hotels will serve. If you have come to Goa and if you have eaten this, you would really enjoy. But today the situation is, I will just go ahead now. This is basically what we call is the cucullatas, those small ones, small oysters, and these are the big oysters. This is a staple food of Goa. Regularly, you will find this. These are what we call Profia malbarica, and these are the oysters which are served here. So these people, the local community, also have their livelihood depend on this. So if you come now during the month of January to April or May, you will find all across Goa the sale of this particular fish, and we consume. But you can increase your uric acid if you consume a lot. But at the same time, there are these are the tisro, what we call the definitely if you come to any of the restaurant, you will get in Goa this particular dry tisro recipe. Especially many people would prefer this. So these are the different dishes which Goa has been serving. This is very important. Particular you find in Philippines also the Placuna placenta, and this is declared as the under Wildlife Protection Act Schedule 4 species. But unfortunately, this species again the only one location where I was talking to about where the marina was being proposed in Goa, where in Sankwal, this is the only place where you find the brood stock, that is a breeding stock of this particular Placuna placenta. And in olden days, they were abundantly available, so people have also designed it. That's called also a window pane oyster. So olden Portuguese houses have, even today, many of the modern houses are also designing their windows in this fashion. So these particular shells, single 1, 2, 3, all these shells have been cut in a square shape and they have been put in this wooden frame. So it looks very beautiful. Many of our Portuguese houses will still have these Placuna placenta, but this is given particularly a conservation status in the state of Goa. But this is a very alarming situation. We find all these such situations in the environment where a lot of chemicals, a lot of toxins have been released. So now, if you observe this carefully, what I'm talking to about is the Saint Jacinth Island. This is a small island. If you are coming to Goa, you have to pass by this. If you are passing from Sankwal, from airport, you will find this. If you see here, there was nothing previously. If you see here, there was nothing here. And even here, if you see, there was no shipyards here. Now, recently, all these shipyards have been permitted. This is 2003 and this is 2022. You see the situation here, and all these barges, all these heavy vessels in the river is being repaired, and all the heavy metals are thrown in the water. So wherever this Placuna placenta and the Paphia malbarica or any other mussel naturally available, these are the areas which are highly being polluted because of a lot of pollutants going into the river. Similarly, if you see, this is a major shipyard in Goa, where you have the major composition of Pernavidis, Paphia malbarica, the cucullatas, the Cassostrea, madracensis. So all this area is, and this is the biggest mudflat, what we call in Goa. Sankwal is the biggest mudflat. During the high tide, the exposed area, which is called as the mudflat, is this is the place where you have the biggest mudflat in Goa, and which serves lot of local community with these harvesting of these species of mussel for their livelihood. But however, the question arises how healthy they are and for consumption. So if you see here, this is another area near Zuari. Earlier there was nothing here. When 2012, this is in 2003 or 2005, and this is in 2012, when the mining was banned in Goa, all the barges were literally blocking this, even the navigation of this island. This is a small island, and people were doing agriculture land here. Now, due to intrusion of salt water, nobody is doing any sort of agriculture activities here. But these barges, which have created problem of increase of lead, cadmium, and mercury because of their ill activities in these water bodies. So all these areas are provided, all the facilitated for repair of barges, parking of barges have really ruined this whole area, and the mussels have also disappeared from this area. There are major jetties also in Goa. This is the High Court now recently, which has come to Porvorim. If you see this area here, earlier it was a prime forest here, nothing was there. And this is a major what do you call parking of all the trawlers from the fishing activity. So these are the Mandavi River, where now the third bridge has already come here, the Atal Setu, what you call. Earlier there was only two bridges. Now the center there is one more bridge. So all these areas where mussel were available, today they are disappearing, or either if they are available, they are literally polluted with all the toxins, and lot of waste and biofouling is happening in these areas. So these are some of the areas which are highly being contaminated with the toxic heavy metals. And there are different sources of cadmium sources, which are metal smelters, the coal burning, the incinerations, and so on. So toxic heavy metals, definitely in a non-smoking population, food is the greatest source of exposure. So high quality of cadmium can be found in crustaceans, mollusks, offals, and algae products. So however, grain, vegetables, and starchy roots and tubers may also contain high quantity of cadmium. And most plant bioaccumulates metal toxins like cadmium and is composted to form organic fertilizers, yield a product which can often contain high amount of metal toxins. So we are really it's an alarming situation where we are having all these food, and the toxins in your favorite food, go of seafood, you have no idea existed. So this is an alarming cause given to us by even the scientists in the Goa National Institute of Oceanography, which are the traces of cadmium and chemicals found in car batteries and used in the nuclear fission processes are showing up in the edible saltwater oyster in Goa, which is a very alarming situation. So there are a lot of research which has happened where the concentration of heavy metal in commercially important oysters from Goa, which is central west coast of India. And there was one scientist who was a microbiologist in Goa. He is no more. Recently he expired. He was a excellent environmentalist, containing heavy metal pollution by bioremediation. So there were a lot of conflict which took place during those days, where when these type of research started coming out, where people stopped eating these mussels and the oysters. And water pollution killing Goa marine population blows to seafood lovers environmental in future. So here one of the area, even I was that time a part of this particular initiative, where suddenly all the mollusks started dying in one of the area. And then later it was analyzed that there was a lot of sewage, the industrial waste was released suddenly, and the water was tested, and a lot of such heavy toxic material was detected in this particular river. And then the directives was given by the fisheries department, by the pollution control board, the environment department, to stop this immediately, and then it was revived, fortunately. But these were the areas which were highly. So total mercury and methyl mercury in commercial marine species from the Goa coast, constraints or risk assessment and environmental issues. These were some of the research which was done in the 2019, and still a lot of research is happening. I will not go into detail of this. So effect of mining activities on a clam fisheries and bottom fauna of the Goa estuary. So if I say here, this is the research in definitely in 85. And those days, and even today, when we talk about the mining, the mining has definitely the lot of silt has been washed away from the higher elevations to the lower elevation in this river. And wherever there were fisheries, wherever there were mollusks or the mussels, those beds are covered with this silt. And that is how the loss of the bed of these Porphyria malbarica or the Paranaviridis or Meretrix have lost in the state of Goa. So very few places now these particular fishes, the mollusks, are found. And effect of mining activities on a clam fisheries and bottom fauna of our estuaries, a lot of research has happened. I will not go into detail of this. Impact of petroleum products is also in Goa. We are facing the southwest monsoons. During those days, we are facing a lot of issues of tar balls. I will talk to you in further slides. So use of fossil fuels such as petroleum has a negative impact on Earth biosphere, and that is how the government initiative across and also across the globe, we are talking about the electric vehicles and use of fuels may be reduced, and emission of carbon can be also reduced if we take certain steps. And toxic petroleum products like oil spillage in the rivers, I think probably there is one issue, Exxon Valdez oil spill in Alaska, what in 1989, which was a major tragedy and well-known hazard, where the ship struck the reef, and which caused 11 million gallons of crude oil to spill into the water, which was a major accident. And that time, people, around 4 people died, and many were affected, like around 672,000 were reported with illnesses because of where they were involved directly in cleaning up. And there was a tremendous loss, or the commercial value of salmon fish diversity was drastically affected during those days. So it was a real tragedy where toxic petroleum oil spillage can take away. So there are a lot of wildlife like birds, the coastal birds, the migratory birds were also affected because of this. So these are the environmental impacts. And toxic petroleum, the oil spillage, the turtles are also not being spared. The fishing communities claim that hundreds of fish had died those days. And Alaska fishermen still struggling 21 years after Exxon spill. So it is a real tragedy. And I would like to also highlight there is in Asia, this is the second largest fishing hub in Goa, the Karandalem beach, what we call, where the large community of fisherfolk community enjoy this fish catch, and the whole livelihood depends on this particular Karandalem beach. You might be seeing there are a lot of different fish. If you come to Goa, you will find tremendously people are catching this fish, and lot of people are dependent on this fisherfolk community for the fish diversity, good fish consumption in the state. And you will find a multiple different types of species in this particular. And recently one new species, I mean not new species, I'm not getting the name. Recently it has been newly recorded one species on this particular Karandalem beach. So the people are really enjoying, but recently due to tarball issues, the oil spillage here, this is the governor house here in Raj Bhavan, and this is the Arabian Sea, and this is the Mandavi River here this side, and this is the coast of Miramar and the Karandalem beach. So you get a major catch in this particular area, but the quality of fish is really excellent, and anybody can consume this. But still we are trying to analyze through one of the project whether these fishes are also having contaminants or toxins in this. Especially we are also working on the microplastic. So this is the situation when toxic petroleum products, the tar balls forms on the beaches. And when the tourist season, exactly it coincides with the tourist season. The tar balls are formed from the weathering of crude oil that are carried many miles and can be deposited on beaches. So go on beaches, you'll find completely black like this during this season. So when there's a southwest monsoon, the whole that tar balls will be coming and settling during the high tide on the beaches. And tar balls resurface to silly Goa beaches, no solution in sight. So there are a lot of pressure on the government, a lot of pressure on the coastline, and a lot of issues crops up because of all this. And we are also working on the microplastics, especially on the shellfishes like Meritix casta, the Paphia malbarica. We're also working on freshwater gastropods to find out what is really happening in the environment. So we are also finding a lot of fragments of any type of plastic less than a 5 mm, which are still I am not concluding the study. One of our faculty, Dr. Abelino Di Costa, is working extensively on this particular aspect, and we are trying to see how best we can resolve this in a larger perspective. So there are a lot of these, and these are some of the major, again, serious issues: sewage and plastic, and the water contaminants and other heavy toxic metals which are being released in a very prime area. And as you see, microplastic in Goa tap water sample studies. So we had a Goa Sal River contaminated by microplastic. The fish, shellfish laced with polymers. It was a very alarming situation those days. And after Goa, the 33 beaches in Karnataka are contaminated the most with plastic with a concentration of 21.91 grams per square, followed by 12 beaches in Gujarat at an average of 12.62 grams per. So it is really, we need to think very positively, and these are all the different, situations and the solutions which we can come out with if you want. And this is the impact of microplastic on the fish. And definitely we are working on this. One of the publication will be coming up. We have found out some different microplastics in the fishes, but we are yet to conclude it. We are still working on it. So the fish, we at least remove the liver, we clean it and eat. But for mussels, we don't do any cleanliness. So it's a mussel. So we just cook it and eat it. So we don't know what is really happening there. And these are some of the other impacts of environment where animals are really suffering with the plastic and stuff like that. I think this is the last slide. Thank you very much. Yeah. If there are any questions, I will be very happy. Professor Mamta. Ma'am.
Hello? Can
Ma'am?
you hear me?
Yeah,
Can you hear me? Camera, please. I think some tech. Just please hold on. Camera, please. Camera, please.
कैमरा आई रिकॉर्ड वहीं से हुआ है, मेरा पता नहीं क्या हुआ है, वहीं से हुआ है. आप बोल दो, मैं देखता हूँ.
Nitin sir, can you please? I think you are the co-host. Can you on that camera?
Yeah, ma'am. Please, I'll do that. Yeah.
So we were just struggling in case what has happened.
Yeah. Can you see me? Yeah.
Yeah, we can see you, Dr. Nitin. Such
I
a
can
pleasure.
see you. Yeah. Thank you so much.
Press my camera.
Yeah, your camera is not on.
Just wait. Just please hold on. Light.
Yeah, please.
Yeah. I just want from where did you get such beautiful photographs, Dr. Sam?
Ma'am, some of them are mine photos and some of them I have taken from the internet actually.
They are very beautiful, and the accent Maldives photographs were horrifying.
Yeah,
Trust me.
thank you.
Maldives was like very horrifying, and it was such an amazing lecture, Dr. Samant. If any questions, please raise your hand so we can unmute you from here. I think a lot of appreciation for you, Dr. Samant.
Thank you so much, ma'am. Thank you so much,
And
ma'am.
people are writing very good things about you.
Yeah, thank you so much, ma'am.
Dr. Samant, can you tell us a bit about your PhD work? I think you work on pit vipers, right?
Yeah. In fact, we have 3 species of pit viper in Goa, and I have worked on these 3 species on the diversity and their how they use the habitat, how they use the perch height, particularly the arboreal species. Now we are working extensively on the diversity of Goa, Maharashtra, Karnataka, and we are trying to analyze how the habitat is being utilized by all these species, so that we can use this for a policy to conserve these particular areas in future, because we are having a lot of pressure on this Western Ghat because of different projects which have been proposed, including the Madhe River diversion, and then there are 3 linear projects, highway passing by, then train passing by, then the other hydroelectric projects have been proposed. So we are working on that direction to understand how best we can conserve these certain areas for conservation purpose, because we are also working on the frogs, and there is a lot of climate change impact on these species because they are habitat specific species. Some of them are habitat specific species. So we are working on different directions to understand how best we can conserve this habitat rather than concentrating on one particular species. So it is very important for all of us to understand how the climate change is also taking away these small individuals, the creatures, even some of the new species have been recorded in these regions. And Goa is such a place, every probably kilometer you may get some new species. So it is a very eco-sensitive state. And when we are doing any development, we need to think positively towards the environment. Right? Yeah.
And Dr. Sawant, you have discovered some new species of some animal, right?
Yeah. It is in fact, we got that in our Goa University campus only. So it is the smallest gecko in Goa. We named it after Goa. It is a Hemiphilodactylus goensis. And
It's a lizard, right?
Yeah, it's a lizard. It's a very tiny, small lizard, and we named it after Goa. It is called as Hemiphilodactylus goensis. Rather, earlier our researchers got it in Karnataka. Then it was found in Odisha, and the third clade was found in Goa. So we named 3 different species in 3 different states. So it was an amazing experience. And one of my students, he was staying in a hostel. He saw that and he tried to work on it. So it was excellent, amazing finding. And now we are having more new species coming up in future. So we are working because day to day we are getting new findings in the state. Yeah.
That's amazing. Please accept my heartiest congratulations.
Thank you, ma'am. Thank you, ma'am. You can see something here behind me.
Yeah, I can.
What I'm pointing.
Dr. Sawant, please.
What I'm pointing out here.
Either pin Dr. Sawant's screen, please. Pin Dr. Sawant's screen. Yeah. Dr. Sawant has discovered one new species of lizard, Hemiphilodactylus goensis. So it's time to show that. Yeah, I can see it now. Show Dr. Sawant.
No, I'm not showing you new species. I'm showing you something else. Can you see this? Can you see this here frame?
Yes, I can.
This was a shawl given to me by Professor Ina Mathur, ma'am. I have framed it because I can't put a shawl. So I always remember when I see that frame.
Yeah. But you developed a butterfly garden also in Goa.
Yes. And I developed 3 butterfly gardens. I developed 3 butterfly gardens for government, and fourth one is going on right now in Goa University campus. And the initially first garden which I developed, we got first.
Even in that shawl and which has.
Yeah, we got in that butterfly garden. In that butterfly garden, we got a new record for the state, that is Tamil scatter butterfly. So yeah,
that's amazing.
Yeah, so we do regularly all these research work continuously. Yeah.
So
any more questions, ma'am? Any more questions?
I can see excellent, beautiful, wonderful, so much good things for you.
I'm planning to bring you to Goa. So just wait for a while.
Yes, we will definitely come. We plan, but
I will be very happy to see you in Goa, ma'am. Please, with always with Hukum Singh, sir. With I will call him, ma'am. I'll invite. Just give me some time. Yeah. For your information, my 9 students are there in Rajasthan right now doing internship with Satyaprakash Mehra.
Okay, that's amazing.
So it was a
great. Dr. Satyaprakash Mehra was working at Thana.
Yes.
9 students are doing internship. His 9 students are doing internship with him. He's a valedictory keynote speaker. That's amazing. That's what ICMSTC is all
exactly.
About.
I'm trying to build a strong relation with Rajasthan. It was great, amazing state. It's an amazing state. With
there's a one bond which connects us is Dr. Ina Mathur.
Yes, ma'am. We should not forget her.
She connects me, you, Dr. Chandani, Dr. Satyaprakash, everyone. She keeps us so much connected. And that's all for that lady, yeah.
And in fact, it was a great that Satyaprakash Mehra ji has organized the whole internship program with all eminent people and my students are so much learning there in different landscapes in Mount Tapu and Sloth Bear, that man-animal conflict and all other landscapes. So it's amazing, ma'am. It's amazing. May I see Hukum Singh Sarji, please?
That's so wonderful to talk to you.
May I say hi to Hukum Singh Sarji? Sarji. Sarji, nice to see you, sir. Sir, nice to see you, sir. And I hope you will come to Goa.
कब आना है सर?
फरवरी में आ जाओ सर, अभी मत आओ, अभी बहुत ट्रैफिक है. So please, I invite all of you. Definitely, I will send the invite. Right? Nice to see you, sir. Nice to see you. I wanted to see you, just see you. Yeah.
We are also very happy to see you. Actually.
Thank you so much, sir. Thank you. Thank you for inviting me for this particular lecture. Thank you.
Thank you so much. It is so wonderful.
Thank you. Yeah.
Thank you so much, pleasure. And on the behalf of the whole organizing committee and from our president, principal, and from everyone, we thank you so much for your time and your deliberation. And we hope to see that you stay connected with us. Thank you so much, Dr. Sam.
Thank you, ma'am. Thank you so much. Thank you so much. Thank you, sir. Thank you, sir. Jain, sir. Jain, sir. Jain. Bye, sir. I will take your leave, ma'am. I will take your leave. Bye.
But we will come.
Bye. Thank you. Thank you.
Yeah, sure. Now we move for second keynote speaker, which is Dr. W.B. Gudane, Dr. Basudeb Gudane. Kindly make him co-host. Yeah. Idhar se mute karo, please. Dr. Basudeb Gudane obtained his MSc degree in chemistry in 1989. He obtained his PhD degree in 2000. Dr. Gudane obtained his MSc degree in chemistry in 1989, and he obtained his PhD degree in 2000 on polymer chemistry from RTM Nagpur University, Nagpur. Dr. Gudane is presently working as a professor and head of the department in chemistry at Kamla Nehru Mahavidyalaya, Nagpur, India. During his research career, he is involved in the synthesis and characterization of nanomaterials as well as the development of SBR nano, composite materials, semiconducting materials, ion exchange resins, biodegradable polymers, conducting polymers, TLC and epoxy resins. Dr. Gudane published more than 230 research papers in national and international reviewed journals and international conferences. He is reviewer of 38 international journals of Elsevier, John Wiley, Springer, Marcel Decker, Bentham, RSC publishers, having impact factor more than 2. He has successfully guided 26 students for PhD. That is a wonderful number. Heartiest congratulations to you, Dr. Gudane. And 8 are currently registered for PhD with him. He has successfully guided 21 MPhil students. डॉक्टर गुरुले आपका बहुत बहुत स्वागत है सर आपका अभिनंदन है और आप you are just like a family. It's been long time since we are working together. It's a pleasure to see you and hear you. So you can start with the deliberation, Dr. Gurule. Sir, please unmute yourself, Dr. Gurule. Pick Dr. Gurule, please. Yeah. Just, sir, you have to unmute yourself. Just following me.
Only one second.
Sir, your deliberation, we are waiting on the screen. Please, sir, Bharat Sada, you can take your time. Okay. एक घंटा लेट हो गया आ रहे meanwhile for admit करो I just spoke to Dr. Gulale. He's about to join us, so let's wait for him. Till then we can see a documentary. Admit करो अपन करते हैं उसको बाद में पहले इसको स्टार्ट कर वो डॉक्यूमेंट्री स्टार्ट कर वो भी डॉक्यूमेंट्री इंडिया की कर दो
पॉल्यूशन किया कैसे
पॉल्यूशन कर दो ऑयल स्पिल कर दो स्पिल हाँ यही कर दो ये वाली सामने जो आई है पहली नहीं डॉक्यूमेंट्री यूट्यूब पे देखो था यूट्यूब पे जाओ हाँ कर दो
National security
Thank you. One. उसके बाद ये सेक्रेटरी जा रहे हैं
कोई कितने खा रहे डॉक्यूमेंट्री
फाइनली ठीक है चेंज कर दो इसको प्रॉपर
BP had an accident here in 2005 where 15 people died.
चलने दो ये ठीक है चलने दो
Well, I'm second injury.
तो पूरा जा तो फिर डॉक्टर
More than state. We came to the final.
So this is all BP, right?
BP declined.
Explosion.
BP in 1999 as part of a $61 billion takeover. Refinery was in bad shape. workers and contractors were wary of the place.
The refinery was not project, but that running down the things that were rusted, that the refinery has been there.
It was chemical for him, and it's turning to fire every week. A fire every week is a warning sign that something is hurting along with the facility. It was the worst refinery around, for sure. When the refinery was under benefits management, major revenues had been postponed. For example, in 1981, and when they were considered replacing its antiquated blowdown used to collect volatile liquids and gases in an emergency with safer, modern flares. They decided against it.
Flares more efficient and safer than wood else. And there were several incidents.
Are you seeing there? Please.
Old
Yeah, yeah, sure, sure. Okay.
Wow.
One go to Dr. Rose, it's Dr.
There's an extreme city. These emails from 2002 reveal that BP had also considered updating the blowdown plans. We need to decide on what to invest $150,000.
So, Dr. Gunule is with us and we can see you, sir. And आपका सर बहुत-बहुत स्वागत आपका अभिनंदन. I've already introduced you to the participants, and these participants are from 26 countries. And it's pleasure to have you. You can start with the deliberation, sir.
Okay, thank you, madam. I'm sharing the screen.
Yeah, sure, sir.
Is the screen visible, madam?
Yes, it's being presented, sir. Yes, we can.
So first of all, I thanks the organizer, particularly especially the principal of the college and Professor Mamta Sharma, madam, for inviting me for this STTP International Training Program 5 number. So once again, thank you, madam. And today's presentation here, I'm giving on the elastoma, that is polymeric materials, which are very important for the environmental conservations. So as we know, polymer materials are, number of materials are there, and we use this material in everyday life. This slide show what are the application of this polymeric material. As we know, polymer are one of the most important substance which have a great impact on our modern life. So here, these material can be used for making these resins or for these covers of these tablets or clothing or these roof of the houses and so many in electronic devices. So man-made fiber, which is the polymerized product, has brought a revolution in the textile industry. And as we know, nylon, natural synthetic, rubber, and plastic resins are the gift from scientists to our society. And as we know, because of these material, our life is now comfortable. And what is now here, there are different terms. Monomers are there, oligomers are there, and finally that is the polymers. So here, it is also possible to synthesize the new compound, what is known as the polymer nanocomposite, by introducing some pillars in the rubber matrix or in the polymer chain. So introduction of this other material like metal oxides, then we get the composite material and which are having versatile application in our daily life. So here, this material can be used for drug delivery, for high performance polymer, for biomedical materials, electrocatalyst, and also for the purification of materials, and also used as electrodes. So these are the wide application of these materials in our daily life. And now here, polymer and polymer composites are the very important materials. Now here, as we are going to see the overview of the elastomer, we should have to know what is the polymer. So there are mainly the three types of polymer depending upon the source: natural, synthetic, and semi-synthetic. So here, how to synthesize, how to characterize, what are the properties of these materials that we are going to discuss in today's part. So here, as we know, nature polymer, which is a source of animal or the plant, and here is this slide show the properties of this material. Here now, uh, there are a number of material, that is cotton from the plant, nature latex from the rubber tree, construction cells are made from the chitin. So these are the different parts where silk from the silkworm, rubber can be used to make the tire, and so all these are the parts. Protein from the eggs and other foods are also natural polymers. So all these are the examples of natural polymer where we can say that proteins, the cellulose or starch are the important natural polymers, which are the source from the plants. And in addition to this natural polymer, two more are there. One is a synthetic polymers and another is a semi-synthetic polymer. And semi-synthetic polymer now also there's a very useful material because it is obtained by a vulcanized, that is the vulcanized rubber is the semi-synthetic, and synthetic or the artificial, which are man-made polymers are the synthetic polymers. But now in addition to that, example of synthetic polymers are the nylon fibers, which are used for making the cloths and fitting nets. And semi-synthetic polymers are very useful because we are adding sulfur during the synthesis of rubber, which is known as vulcanized rubber, and cellulose acetate, that is known as the rayon, are the important polymers. In the classification, mainly there are three types of polymers: linear polymers, branch-chain polymers, and cross-linked network polymers. So here is diagrammatically shown how the linear polymers are there, long chain, and also there is a now branches in the long chain, and also sometimes there is a cross linking, and the cross linking is possible by addition of some other materials. Generally the sulfur can be added to make the cross link in the material. So linear polymers are having a long chain. So here how the repeat units are there. This is the repeat unit. One time it is repeated. So this straight chain having a long chain, and in this case monomer are the they
Admit.
to form the long chain. So these polymers have high melting point and are of having higher density. And common example is the PVC, polyvinyl chloride is the example of linear polymer. And in case of branch chain, having see the straight chain of the and having some branches here. Here are the branches. So in this case, monomer join together to form long straight chain with some branches in the chain of different length. And therefore, we can say that polymers are not closely packed together. They are having low density, also having a low melting point. So LDPE, that is low density polythene, used for plastic bag and also for the general purpose. So we should know what is the structure. So here, third one is the network or crosslink, and in this case, this is the backplate. First synthesize the polymer, and this is the, how they join each other and forming a network type of structure. So these polymers, in this case, monomer contains strong covalent bonds because they are composed of the bifunctional and trifunctional in nature. And these polymers are brittle and hard, and having a network type of structure. Now we can also discuss here what are the molecular forces. So based on the molecular forces, thermoplastic, elastomers, and
टेंथ को तो आओगे ना यही बैठेंगे कल से बस बैठ कल से ही बैठोगे और टेंथ को तो बहुत बड़ा फंक्शन है मतलब आज तो क्या है नोशनल इनॉग्रेशन हुआ है मेन इनॉग्रेशन जब ना फाउंडेशन डे
thermoplastics, and these are the polymers, and these are the soft material, and on application of heat, and this can be molded into desired shape. Example of thermoplastic.
भी चल रहा है अभी तो सेकंड दो और बोलेंगे
मैं कह रहा हूँ मैं 10 है
नहीं अभी तो 5 में है
तो फिर अभी से
अरे अरे 10 तारीख को कॉलेज का फाउंडेशन डे पैदा हुआ था
So examples are polystyrene, polyethylene, and polypropylene are the example of some plastic. Similarly, in thermosets, these are the polymers of individual chain bonded covalently during the polymerization, and on application of the heat, they have their shape cannot be changed. Therefore, known as the thermosets. Once their shape cannot be changed. And example here is given. This is the thermoplastic polystyrene. Styrene undergo polymerization forming polystyrene. And this is the thermosets. Once it is set, it cannot be changed. And next one is the elastomer. So polymer chain, in this case, they have the weak intermolecular forces in case of elastomer, and therefore, because of a weak intermolecular forces between the chain, they have a cross bonds shown here. How the cross bonds are there. Vulcanized rubber is an example of elastomer, and another term is the fiber. And these fibers have strong intermolecular forces. Hydrogen bonds are the dipole-dipole interactions. Because of that, example is shown dimethyl terephthalate undergo polymerization with dimethylene glycol and form perilene. So, different thermoplastic thermosets, elastomer, and the examples are given here. Now, some important features are there about the polymer, and
ऐड करो भाई इसको करना पड़ता है।
elastomer is a polymer with viscoelasticity, means both viscosity and elasticity, and with weak intermolecular forces are there. Generally, they have low Young modulus and high failure strain compared to the other materials. So some important features are also there, and mainly these elastomers are saturated or unsaturated. And here, silicon rubber is a saturated elastomer, unsaturated is a butyl rubber. Here, in case of the saturated, stability against oxygen, if you see here, they have showcase of superior stability as compared to oxygen, radiation, heat, and ozone, and they are less reactive. And in case of unsaturated elastomer, they can be cured with the sulfur and butyl rubber, natural polyisoprene are the examples of unsaturated elastomers. So these are the mainly two types of elastomer we can synthesize in the laboratory. And in the next slide, it is shown that natural rubber, that is elastomer, are obtained from the Hevea brasiliensis is the name of the tree. And in our India, Kerala is the larger producer of these trees, and we obtain the latex from the trees. And in the world, Thailand and Indonesia are the largest producer of this type of latex, and which is the natural, you can see the natural elastomer latex which obtained from the tree. We use can be used as a natural rubber, and in natural rubber, isoprene is the these are the plantation specially made in the Indonesia and Thailand too, and we have to cut the tree in one of the site, and so we can collect in this pot the latex, which is the natural rubber. And the monomer in natural rubber is the isoprene. So this is the structure isoprene, which can be represented here. Cis-14 polyisoprene. This is natural rubber, and this is the trans-14. So it is in a cis and trans isomer. And this natural rubber having the different grade shown here in the slide. This is one ribbon soak sheets. This is the pale clips, and here is a brown blanket type. So three different types of grades are there of this isoprene, which is present in the natural rubber. So this type of grade we have in our laboratory, and we have synthesized also different types of rubber sheets. In case of we have seen the natural, now this is the synthetic rubber. The synthetic rubber is nothing but the man-made rubber, and in this case, different types of articles, the products can be obtained by using the synthetic rubber, and these are the man-made rubbers. We have to modify the rubber, natural rubber, and we can synthesize different types and different shapes. And example are the NBR, nitrile rubber, fluoropene CR, butyl rubber BR, styrene butyl rubber SBR is the well-known rubber synthesized man-made rubbers. So this can be used for making rubber tubes or the some articles useful for the what is the in electronic devices. So synthetic rubbers are very useful to us. Some of the applications are being shown here of these elastomers. Uh, these are the polymers. We should not throw all this material in anywhere. So we have to use generally this polymer which are should be a biodegradable, and also we should use the green technology for making all these materials. So main aim is to prevent the environment. And so here, uh, out of 100%, 65% of the rubber or elastomer are used in a rubber industry, that is the in a automobiles for making a tire industry. And so mainly it is used for making the tires out of 165%, and remaining are used for hand gloves, apron, and all these other articles which are useful to the automobiles. So here surgical gloves are there, heavy gloves, and kitchen cleaning gloves are also there. And in addition to that, here some thread, here is a thread is shown in the tire. Side one, this is the side one. So details have been given how to make this tire by using this elastomer. So these are the articles which are useful to us, and the mainly the product is the elastomer. In case of footwear, these elastomer can also be used, and here is shown some examples. This is the slipper, and here is the shoes, and here some other shoes. Sandals have been shown, and some of the part of the aerospace. So all these are the material which are made by using the elastomer. So we can say that elastomer or the polymer are widely useful material to the society. Here some of the household materials are being shown here. These are some threads, these are the toys, and also these rubber tubing, and these are the robotics, actuators, and activation pacemaker. Everywhere we find these are the households. In case of it, we find all these other materials which are made by using the elastomer. So in short, we can say that there are number of materials which can be used for this purpose, and in short we can say that large number of applications are there of these elastomers or the rubber material. Now, so we have seen what is the application of all these material elastomers. Now, yeah, how to there are, as we have seen, there are elasticity. The materials have elasticity, and therefore elastomer is known. And now here, this is the rubber are coiled and intertwined with the one another. In this case, it's shown when it is stretched, so it becomes straight in this way. So here is shown when it is stressed, it is like this. But when the trace is removed, then it become again here in this way in the original position. But when stretch is uh, beyond the elastic limit, then they get break, and we get such type of materials. So this is the below elastic limit, and this is beyond elastic limit, because certain materials have some elastic, some are the strong, some are weak, some are hard, some are soft. So depending upon the properties of this material, so beyond the elastic limit, we get this rubber get broken, and here below the elastic limit, rubber is came in the original position, and what is now original coiled conditions are there. So this is the elasticity which is present in this material. Therefore, this is known as the elastomers. So now, if we want to make the composite materials of these, which are having lot of applications, so for that case, we should have to uh, perform these three important processes are there. One is the mixing, and second is the compounding, third is the vulcanization. So in this case, ingredient required for making the composite material of this rubber, we can take SBR, we can take BR, we can take any other polymeric material and elastomer, and we have to modify it and to make the composite. For that, composition is required, ingredients are required. Here is a natural rubber. In place of that, SBR can also be used, and 100 PHR, and this carbon black, this is the filler. We can change depending upon the 1 PHR, 2 PHR, we can vary it. And other accelerator, what is the stabilizers? We have to add all these. Sulfur is a hardener. We have to add after making all this composition. We have to mix all these materials. After compounding, what is now here? Rubber. This is the recipe for making the rubber composite. and in case of nitrile rubber composite. So in case of NBR, nitrile butyl rubber here, 100 amount. So here accelerator in 2 phr, so activator 2 phr, 3 phr, activator stearic acid can be used. Here activator is a zinc oxide and carbon black, silica or any other tin oxide, antimony oxide can be used as a filler, and this can be changed. So these are the ingredients. So three important parts are there. First of all, mixing, then compounding, and then vulcanization. So all these are the important part. So during this process of mixing, compounding, and vulcanization of the rubber, these are the important three steps. In case, as we know, there are natural rubber and synthetic rubber. And natural rubber have high tensile strength and are resistant to wear and abrasion, water repellent. But in case of synthetic rubber, having lot of properties and importance, uh, it is the synthetic rubber is a flexible and also durable, and it can be molded when heated, and it is also resistant to heat, light, and the chemicals, and have the better abrasion resistance, and also having a flame retardant, resistant to the grease oil. So, as compared to synthetic, natural or synthetic rubber are very useful material. So, to synthesize the synthetic rubber, all these other this slide shows. Important method is the two-roll mill. For this, after making the mixture, we have to pour the mixture of the compounding here. Here are the two rolls. This is the one roll. Another roll is here, having a 10-ton weightage. And so we have to apply here 5 or 10, depending upon the material. So we have to apply the hydraulic press here, and these two rolls are moving in opposite direction, and we have to pour the solution between these two wheels. So here two roll, and here is shown how to pour the mixture. So this is the mixture between the two. This is and these two rolls are moving in opposite direction. One is anti-clockwise, another is anti-clockwise. So here is shown. Here is the how to pour the mixture, and after mixing here we have to after pouring, and these rolls are moving in opposite. So we get, because of the high uh, pressure, we are getting here the sheet which is obtained, which is a rough sheet. The rubber sheet which obtained by using this two roll mill is a rough sheet. It is not fine. So to make it fine, what is compression molding machine is shown here. So this is the machine. Again here we have to apply some temperature of 161, and after that we have to use the pressure also, and under pressure and the appropriate weightage and temperature, we have to press the rough rubber sheet here for the 2 minutes only, and at particular temperature, and then remove it. After that we get the fine sheet, and also it is possible to make the different colored sheets in this case also. So during this process, uh, fine sheets is obtained, and this sheet can be used for different purposes, for making what is the shoe sole, or for making any rubber tubing or whatever like that. So this is here in two roll mill we get rough sheet, here we get the fine sheet. And also if we want color, we have to mix some color pigment, yellow, red, or blue, so that we can get the rubber colored sheets of rubber, and depending upon the pigment used for that color pigment. So these are the important requirement. Two roll mill, and after that compound compressing molding machine. So after that we get the sheet. uh, then vulcanization, sulfur we have to use generally to vulcanize the rubber obtained, to make it hard, and also to cross link. So this figure shows how the chemical bonds are. Here are the chemical bonds, and physical cross links are also there, and entanglement is also shown somewhere here. This is here. And so here, after adding during the synthesis, we have to add some amount of sulfur. So this type of bondings have been shown in the during the process of vulcanization. So, and there are sulfur vulcanization systems are there. Yeah, this is the vulcanized. This is the vulcanized. So before vulcanization, this is the structure of rubber molecule. So in this way, rubbers are there. But when we add sulfur, what is we get? Here is a link shown. These are the separate. Now between these two, link is there because of this sulfur. This is the cross link shown here in this way. So this clearly shows before sulfur vulcanization and then after vulcanization. So sulfur can be used as a cross link agent, and it is also economical because it is not costly. Therefore, it can be used generally during the process of vulcanization of the elastomer or the rubber. Now here, sulfur dose, accelerator type, and accelerator sulfur ratio, cure time, all these are the important part in this synthesis of rubber. And here is shown sulfur cure system. Now after adding sulfur, what is the, we can classify this CV, that is conventional curve, cure, efficient vulcanization, semi-efficient vulcanization. So after now it depends upon the rubber or elastomer. The rubber combined with the sulfur, and that sulfur introduced in the polymer chain and forming the sulfur cross links. So depending upon that, sulfur dose, how many pH, how much pHR is there, accelerator dose, and also accelerator sulfur ratio. All these three are the important part. And we get conventional type here is shown, and efficient if you want, we have to take this is the ratio, and semi-efficient then we have to use this ratio. So depending upon that sulfur ratio, doses, we have to apply sulfur accelerator doses and accelerator shown here in this table. Now advantages of these vulcanization systems being shown. This table clearly shows different types of conventional, semi and economical vulcanized. So what are the here properties of is shown here, and polymer is shown here. And in this case, cyclic sulfide concentration should be, in case of conventional, high, in case of the semi, medium, then low. So all these are the properties we have to maintain to make the different types of vulcanized systems. So depending upon the properties, we can make different types of vulcanization systems. And in addition to that, other cross-linking systems, by using for that, peroxide curing can also be possible. So peroxide can be used to cure many elastomer, and in this case, in place of the sulfur, unsaturated bonds in the polymer can form, and in this case, ether type of polyurethanes, certain fluoroelastomers, silicons, all other saturated elastomers, in which we can use this also peroxide curing in place of sulfur. So this here is shown, this alkoxide, and forming here, these are the reaction shown how alkoxide is formed. So R's OOR, it get break and we get two molecules of this is the active, and it get react with the polymer and forming this type of chain. So in this way, this group get joined and we get the long chain. So here is used the peroxide curing compound. Other cross-linking system is also possible by using the radiation, vulcanization by radiation in place of sulfur peroxide. Now radiation, it is also possible. For this case, different types of radiation we have to use. For this case, generation of, in this case, reactive form is the radical. In this case, the shown here, what is this is the rubber matrix, this is the sulfur, L star is the radical sulfur, and zinc is shown here somewhere. So electron beam we have to pass, radiation we have to pass through the material. Then what is the cross linking is possible shown here. This is before cross linking, and after cross linking we get this type of material. So this is the thermally vulcanized rubber. This is vulcanized. There is some cross linkings shown here. So by radiation, after passing radiation also, or electron beam of radiation through the material, there is also some cross links are being shown in the material or matrix. In case of vulcanization agents, accelerator, all these are the important terms during the process of vulcanization. One is a accelerator, is important activator, anti-degradant, antioxidant, plasticizer, flame retarder. All these are the important properties for vulcanizing the elastomer material and can be used as agents. So during the accelerator, here the examples have been shown. What type of accelerator can be used? So here is shown. These are the examples, and here is the chemical group which is present in this accelerator. Vulcanization speed, whether it is slow or fast, have been shown in this slide. So accelerator is very important during the synthesis and vulcanization process of elastomers. So depending upon the group present in the, whether it is aldehyde group, guanidine, thiazole, and depending upon that, we get the material, and their properties are also different. And here primary and secondary accelerators are there mainly, and primary accelerators are used at 0.5 to 1.5 phr, and in this case doses we have to apply, and most rubber compounds. Now here basic accelerator like guanidine, thiourea, dithiocarbamate, like this we have to use sometime as a secondary accelerator, and secondary accelerators activate the primary accelerator. So here is shown some primary examples and secondary examples of the accelerator. So it may be a primary or secondary, and depending upon the group. And in this case, activators is also another important part. These are used to prevent the chain from moving independently and allowing the material to stretch under stress and then return to its original shape when the stress is released. So this is the material which can be used for this purpose. So whether under the stress, it get stressed, but when it return, it get in a original shape. So this is the important part of the activator. And zinc oxide, some other materials, magnesium oxide can also be used as a activator during the process. Anti-degradant is another important agent which is used during the process, and anti-degradant is especially used for during the light colored product, and it performs the excellent in tire side wall. They have excellent thermal stability, anti-aging for the polymers, and therefore we can say that the ingredient in rubber compound is to determine the aging of rubber product. Anti-degradant include the antioxidant and the anti-ozonate. So this is the important part in case of anti-degradant. This is another useful compound which is added during the process. Here type of degradation is shown here. This slide, how it causes the degradation, types of failure, details of these properties of this anti-degradant when applied is shown in this slide. Anti-degradant are also categorized as primary anti, secondary anti-degradant. So examples have been shown which is useful for this material. So mechanism of this oxyradical scavenging. So here is shown how they primary antioxidant, how donate the hydrogen to the alkoxy and hydroxy radicals is shown here. So this is the one of the compound, and alkoxide, carboxylic acid can be used. And what is now there is a antioxidant donate hydrogen to the alkoxy or hydroxy here is shown. And another, this is the combination of with free radical scavengers, primary antioxidant to achieve the inhibition effect. So this is the general mechanism of peroxide decomposition in this case. So anti-degradant may be primary or secondary, and after that one more important part is the plasticizer. This is the material necessary in rubber formulation for improving the processing of the rubber by lowering the compound's viscosity, and also for aiding the low temperature, and therefore flexibility of the formulated rubber is possible. The advantage of this oil is that it is a powerful plasticizer in compounding during the process of the rubber. And important of plasticizer is that they are used to convert PVC, or we can say that rigid plastic, into soft flexible plastic material. So this is the main part of this. So to convert rigid into soft flexible material, these plasticizers generally used. So selection of plasticizer for elastomers, examples are being shown here. Common plasticizer used in an elastomer compound are the mineral oil, esters, like phthalates, sebacates, and adipates are the example can be used as a plasticizer for elastomers. And plasticizers are mainly three here can be grouped into mineral oils, natural products, synthetic plasticizers are also there. So these are the mainly three types of plasticizers. And uh, in case of flame retardant, another property means this material lower down the temperature before the fire. So we can say that fire retardant we can say that is referred to the variety of substances that are added to the combustible material, and it prevent the fire from the starting or slow down the speed of the fire. So it either it slow down the speed of the fire or prevent the fire from the starting point. So these materials are the fire retardant. It slow down the speed of that fire and therefore huge edge. And most of the hydrocarbon rubbers are flammable or combustible substances. But now when we use such type of nanofillers in that during the process, what is then? It is a flame retardant material. And some factors are there in flammability. For that amount of flammable volatiles, free radical propagation, activation energy, decomposition temperature, oxygen level, all these are the part during the flammability. So in this case, reinforcement is also very important part. Uh, for this, first to make such type of material, what is reinforcement? Need of filler. So generally the reinforcement is carried out by the some other nano fillers, and for that case, after adding this nanofiller in the material, they improve some properties. They improve the mechanical properties, hardness, elongation at break, thermal properties, electrical properties, ion resistance, abrasion resistance, ozone resistance. And in short, we can say that there is an improvement in the properties. As the concentration increases, tensile strength also increases, and some other properties like flame retardant, thermal properties, thermal stability, abrasion resistance increases. So depending upon the properties of the material and which nanofiller we are adding, that is very important part. So the carbon black can also be used as a filler. What is silica can also be used. Clay can also be used. Nano clay, nano carbon black, or the for the reinforcement of the rubber. In our laboratory, we have synthesized number of rubber compounds by using natural rubber, synthetic rubber. We have also modified, and now here is the classification of fillers have been shown. According to the color, black fillers, white fillers are there. What are the examples of being given? In case of black, carbon black. According to the effect, reinforcing precipitated silica, kaolin, calcium silicate, are have been shown here. The particle size is less. Because of that, they occupy the space in the polymer matrix, and therefore they enhance the properties of the material. So there are mainly two types. Here is scale is shown also, non-reinforcing and semi-reinforcing. So what are the properties of the reinforcing, and that is shown here. Important part is that when we introduce nanofiller in the polymer matrix or rubber matrix, then the enhancement of the properties take place because higher polymer filler interactions are there as compared to the filler interactions are there. And in case of SBR rubber or the natural rubber, nano carbon black or some other silicate or the clay can also be used as a nanofiller. And important part is to increase or to enhance the all the properties. Carbon black can also be used and easily available and having low cost. And carbon black obtained from following different processes. These are the processes by which we obtain the carbon black. So either you can purchase from the market, or we can also synthesize in the laboratory by using these other process: thermal black process, acetylene black process, black channel black process, lamp black process. Also, we get the carbon black. If you take also the lamp and keep it for slow flame and keep it for in a window for a long time, 1 month, what is then? Carbon get collect on the wall. So that is nothing but the carbon black also, which is also in nano size. It is formed because of this slow combustion process. So different processes are there to get the carbon black. And advantages and disadvantages of carbon black is there. So mostly it is having excellent properties, and therefore carbon black commonly used in a tire industry to make the tire. And because we know the majority of the this carbon black used mostly in the because the tire or shoes sole are in a black color, and because of that they generally use carbon black, most widely used material. Silica in place of that can also be used for making the composite by introducing the filler to enhance the properties. Silica is also widely used in a tire also sometimes. And here is shown what is the green tire, which is a silica sealant system in which three tangles have been shown. Here is the weight grip shown here. This is the wear resistance. Here is the silica sealant and carbon black is used. So rolling resistance is there of this tire. So silica in place of carbon black can also be used. And this is the green technology where we can apply this method to make the tire in tire industry and our automobiles. So here, green technology is a much persistent to the tire for making. And this is the awesome tire which made in the Europe nowadays, and in future also such type of green tire may come. And in Europe they have designed keeping in mind that both lightness and aerodynamics properties extremely necessary for the strong grip on the road. And so such type of awesome uh, this is the silica particles which is introduced in the tire, and these are the properties. And main improvement is there in a tire strength, cut chips, and what is the rolling resistance, increase the abrasion resistance, weight tension, and all these are the because of the using of the silica. So this is the awesome tire, which is a green tire made in the Europe. And this so what is the resistance? Rolling resistance decreases and because of very useful. And nowadays, nanomaterials are also using in the cement. So for that case also, this compound silica as a filler in the elastomer are very useful to perform the green. And these are the distribution of silica molecule particles in the during the reinforcement of the rubber. So we can say that here majority of the properties. And here uh, uh, this silica when we use here, how it green does the green tire work. So here we can say that in this case eco it is a eco-friendly and reduce the fuel consumption, and also affect which is affected by the rolling resistance of the tire. Tire thread on the surface create the friction. The more is the friction, high is the fuel consumption, and therefore green tire reduces the amount of friction, and therefore, in other words, we can say that lowering the rolling resistance. It means the vehicle fitted with the types of tire won't consume much fuel, and therefore, while the traveling. So therefore, silica sealant system is a very useful, and fuel consumption is up to 8%. So what is this is the most useful material for this tire industry and some. In addition to silica, also carbon black, silica, carbon carbonate, kaolin, clay can also be used as a filler in the rubber matrix. And there is a filler interaction, rubber filler interactions are also there. And most of the properties here is shown. Composite properties, mechanical properties, rheological properties, thermal properties, dynamic, mechanical analysis, dielectric studies, different resistance, morphology, XRD study of all these composite materials can be carried out, and we can characterize all these materials. So these are the properties generally used for composite of these elastomers. So rheological studies is also there, and in case of rheological studies, uh, here retardation factors and some other factors are there. And in this case, to know the behavior of the material uh, uh, during the uh, during the process, and that behavior is nothing but a rheological properties which is obtained in this case. And uh, MDR is the testing equipment used for this rubber compound. And here is shown this MDR. This is the machine, and graph is obtained here, reference standard for this case. And in this case, reference standard here is shown. Uh, Initially, here is a time on this axis, and here is the deduction of the scale, and curing is here around this. Over curing is here, and after that, there are the three part marching, plateau, and a reversion. So all these is the graph obtained by using this MDR rheometer. And to know the behavior of this rubber, we have to know this property. So in this case, uh, we know detail about the nature of this during the process. And important here parameters which are required for this case as shown here: pause time, TS1, TS2, torque, minimum torque, maximum torque. All these are the parameters obtained for this rubber matrix. Mechanical properties are also very important, and in case of mechanical properties, uh, tensile strain, modules, stress to particular strain. This is the instrument where we can use UTM. And here is the first of all, we have to take a rubber sheet and we have to make it or cut it in this shape, dumbbell shape, in different desired shape. After making this dumbbell shape, we have to attach here, and one part is here, another part. What is then? What is the tensile strain can be measured, and also elongate it. So what is then elongation at break can also be known. So in the same way. So these mechanical properties obtained and can be determined here by using a UTM, that is universal testing machine. So it is shown. So these are the properties, mechanical properties can be known of this elastomer. In case of thermal properties, what is the onset temperature, gas transition temperature, specific heat capacity, whether it is thermally stable or not, can be known by using a TG DTA and also differential scanning calorimetry. So most of the rubbers are thermally stable, and if we adding the filler in the polymer matrix or elastomer, then again the thermal stability increases. Now there are some effect is also being we have been observed that silane integrated sol gel derived in the silica. So NBR rubber, the nitrile rubber can also be synthesized, and in which we can improve the properties by adding some other material that is silica like that. So it is also possible to improve the properties and to improve the mechanical properties of the NBR rubber. So here is shown the reaction of NBR rubber can be improved the properties. This is the TEOS, and here after hydrolysis we get such type of material, and after condensation we get this is the selenized silica. So this is the reaction how we get, and this is the composition for getting the getting here nitrile NBR rubber. Rheology study is also carried out, and these are the different parameter for NBR is obtained. Tycho time, Tycho, maximum Tycho, delta Tycho, all these are the parameter obtained for the NBR rubber. And it is also obtained a stress strain study. This is important in case of elastomer. So all these are the parameters have been shown how to make it, and this is the graph which shows how stress strain is there, which is obtained for this elastomer, and after adding fillers, it enhance the properties. After making this sheet, and also same can be used to know the size of surface particle size of the material, what is inside in the bulk of the material, what is the size of the particle on the surface and also inside can be known from the TEM, and also image obtained from that we know the nature of the material synthesized elastomer. Morphology obtained for the one of the SBR nanoparticles, carbon black. So this is the nature of the surface morphology of the obtained by the TEM. These are the TEM images of different resolutions, and this image shows some black colored silica particles dispersed over the gray colored rubber matrix. So here is shown blackish spots. So different type of nature observations we obtain from the TEM and particle size, and different parameters we get from these images. Raman spectroscopy also shows for this rubber elastomer, and different peaks observed, and which confirm the Raman shift, and from that the compound whether it formed SBR carbon black is known, whether it is formed or not can be known by using the Raman spectra of that particular. This is the thermogram and also thermal stability. So here it is starting, and what is now it become constant, then it undergo degradation and become constant here. So and after that here is a no further degradation is there. So different steps are there. One break is here, another break is here, another slight break is here. So what is the structure and degradation pattern and thermal stability? So we can say that it is thermally stable, and this thermogram shows for this SBR carbon black composite. So we can carry out the thermal stability. So in the last, in the summary and conclusion, I can say that these are the material which can be used for the different purposes to the society, particularly in the automobiles and different articles of the aerospace and other household materials. And there are different ways to synthesize emulsion. Uh, Immersion polymerization method is also there. Two roll mill method after compounding and mixing. A method is also there to make the rubber sheets, elastomers, and we can also improve the properties of this material by enhancing, by adding the filler, nano filler like silica, carbon black, or clay, or any other carbonate silicate materials. And depending upon the rubber, with which rubber we are using, natural rubber or the artificial. So SBR can be used for making this type of composite materials, or natural rubber sometimes also. Biodegradable filler can also be used. Biological fillers, so they are, which can also be used to reinforce the material. And after reinforcing, we can apply this material to make these different articles. So in conclusion, we can say that this is another field. We have to use the plastic or elastomer material, and do not throw anywhere. So collect it properly and try to use the green method, and to use the polymer of the biodegradable, so that we save the environment. So all these are the, as we know, polymer are the uh, materials and widely used. And this is the age of polymer, we can say that. And also another new age is the nanomaterials. So there is a combination of both these materials and making the composite material. So these composites are very, very useful to the society. So and while working in this field, we should have to take care. We have to use some green methods, and we have to take care about the materials, because if it is not biodegradable, then there may be a harm to the environment. So these are the methods of synthesis of some rubber and elastomers, and how to know the properties and application that have been given here. So thank you once again here for this uh, all the audience. And if you're having any doubt or any uh, point to discuss, you can ask.
Thank you, Dr. Gundale. That was such a wonderful lecture. Even I was hearing very, very sincerely, and I appreciate your efforts so much. And I can tell you, you are a wonderful researcher. You speak so well, but equally you have devoted a lot of time of your life in research. And I can see a lot of appreciation for you. That excellent, beautiful, nice lecture. If anyone has any questions, please let us know. Raise your hand, so we can unmute you from here. And if not, you can write to us. We will forward your questions to Dr. Gundale. So I would like to thank on the behalf of the whole organizing committee and from RRC, Albert, from my mentor and principal, and from my side, Dr. Gundale, for taking out time and being a part of us. Now you are a family. It's long time since we've been working together, and it's such a pleasure to meet you as a person as well. And trust me, every delegate have liked you so much. Thank you so much once again, and I expect that you will join us in our future events also. Thank you so much, sir.
Thank you, madam. Thank you.
Thank you so much, sir.
Thank you.
So now we move on to our third keynote speaker, who is Dr. Prem Nagresh Lekhi. Dr. Lekhi is joining us from Malaysia. Dr. Lekhi is a medical doctor, and he's from Perak, Malaysia, as I told you. He is a member of Doctors COVID-19 Task Force in Malaysia. Dr. Lekhi has contributed a lot during the COVID situation, and he is responsible for saving many lives. He has been recipient of many awards. The list is long, but the one which I would like to mention is Vishisht Chikitsak Award for Medical Profession and Community Service. I have met Dr. Lekhi in person, and he's a wonderful person and a lot of affection for India you carry, sir. He is member of many communities who are working for the mankind, and I think that's what we expect from a medical doctor. He has been the speaker in many plenary sessions. He is a keen researcher as well, and he gave his service to the society and complete a duty of a good doctor. So without taking much time, I would request Dr. Lekhi to kindly start with keynote address. Dr. Lekhi, if you are there, please start with your keynote address.
Yes, namaste,
Namaste.
India. Namaste, Professor Hukum sir. Namaste, Dr. Mamta, for your very, very kind words. Always, as usual, uh, you are very kind. Thank you for this opportunity. It's a great honor to join you from thousands of kilometers. But as I say, we are all in each other's hearts, always. And I wish and congratulate you for your great program that you are holding. Um, Thank you for the screen sharing as well. Um, so from the onset, I want to really be very proud of this fact that your international short-term training programs now you have reached the level 5. And today's topic on the production and regulation of chemicals and toxins for environmental conservation, very close to my heart. And there are a few personal pictures to explain that. So from an autonomous college from the campus here, I want to really share your joy. As you always put it in green greetings, and people will wear green. That is my color of my own house. I want to share something from the very beginning here. When I say green greetings from Malaysia, we just had a very big news in Malaysia just today, put on my table here now, that an oil palm plantation in Malaysia has been picked as the Earthshot Prize finalist.
Dr. Lekhi, can you hear me? Dr. Lekhi?
Yes.
Sir, we put on your slides, so whenever we have to move the slides, just let us know. We'll move from here.
Okay, great. Just give me 1 minute. I have something. Okay, let's move forward, please. Next slide.
Next slide, next.
Yeah. Okay. Yeah, you can just move a few. They may be just pleasantries
Next.
to the real content. Okay. Current concerns. So you just hold on here. We have this current concerns now in the world where the public health and the global climate change and the ozone layer depletion and the pollution towards air and water. You know what's happening in New Delhi, especially deforestation and the overpopulation. Again, India is going to cross China, as the news is. Natural resources depletion. You know what's happening again. Just I saw your documentary. See what's happening by the oil giant here. Loss of biodiversity, waste disposable methods now becoming very questionable, and the environmental toxins is the topic of the day. So can you please go further? So the some interesting facts I want to share here. Okay, let's put it this way. Yeah, go on the earth. Yes, this one. Wonderful. We know we all stay on the same earth, right? We could be different countries. Now, that's interesting, right? And many of us do not take much interest in this subject because it doesn't concern the daily bread and butter grind that we all go through. So it takes years, for us to move around the sun. And it takes a little bit of thinking. We learn this in school, but then we forget in life. Because it doesn't concern us anymore. And that has all the meaning during this climate change crisis that we are going through, especially the COP27 if you are following, especially Egypt, which was a partial success of it. So you can say time taken to orbit the sun 365 days, that's 1 year. Now the diameter, the longitudinal, the latitudinal, well, of course they are all figures, but it's interesting to know that what is the size of our own Earth. The circumference in miles, the equator, the poles, we now travel almost, especially by air, to other countries, and we just want to reach on time. But even thinking that it is round. Interesting, isn't it? The mass of Earth, if somebody asks you, of course, you can Google it. And the age is about 4.6 billion years. So you can just imagine how insignificant we are on Earth. And as the organizers, the Save the Mother Earth, how are we going to save it if we don't even know what is Earth? So we are mostly on the equator belt, and we are on the tropical rainforest areas in Germany, not very far from each other. So the poles and the directions, the seasons, if you just put them into what we call infographics, it's quite interesting. Okay, next slide, please. Thank you very much. Earth's composition, surface area, we say, okay, 1/4 is land and 3/4 is water. And so someone has done this hard work, finding out how many square miles of land we are and how much water do we have and the water volume. Just look at the figures. Easy to put them in percentage. So Earth's composition. Now here comes the crux of the problem that we are going to discuss today. How much iron we have and oxygen. Yes, please, thank you. And silicon and magnesium and nickel and sulfur and titanium. Okay. So the layer, the thickness, the crust, the mantle, the core, the outer core and the inner core. And we know the temperature. Well, we all talk about it, 13,000 Fahrenheit. You can do that in centigrades. Okay, time zone. Well, it could be, well, it's now about 5 p.m. You are 2:30 p.m. in India and 5 p.m. in Malaysia. So this is what time zone is all about. So we go by the GMT, the Greenwich Median Line Time, as we call it. And do you know Kiribati is an island in the Pacific? It's the place where the first sunlight comes. Well, is this good question for the quiz for people who want to learn something? So when I prepared such lessons, I actually learned myself. So time zone is important. If it is like somebody in America now at this moment is already 12 hours behind, and somebody in Japan, Australia, they are ahead. So global population growth. Next one, please. Global population growth. Okay, I will continue. The world population growth. Now, do you know that we have been just, shall I say, the world dedicated to 8 billion people? That's to our world population. We are now 8 billion on fixed land. So things are getting quite crowded, right? Let's see if you understand what I mean. Because we have 1/4 of land only, and 3/4 is water. And we have to learn to adjust. And there's something called a developed world and an underdeveloped world or a developing world. So let's not get into the intricacies of how this is happening and the environmental resistance and the population always stabilizes at some point. I think we will, but as I will say, and you also know it because you're in India now, that they are going to cross China to be 2050. That's the parameter they have set. Now, is that good news? Now you have to think about it. Okay, the next one is population size dynamics. Interesting though. Thank you very much. Usually, they have the older adults, which is like 60 plus, and we call them senior citizens. And now there's a 15 to 59-year-old group, and then there's the children. Let's say 1 to 14, 1 to 15. So there is something on the birth when if you are born on this earth, you also have to go and leave this place one day. So there is an immigration, and there's called something emigration. So we can immigrate to a country, but one day we have to leave as well. So that takes place as to how many births take place, say, in a second, and how many deaths take place, say, in a second. I don't have those statistics, but I'm just trying to put you on something, a thought that you would have not even thought before. That look at the temporariness, the transient, ephemeral aspect of life, and how we are coming and how we are going. That is very important because it discusses the developed world and the developing world. Because we, as both of you countries, are in the developing world, kind of more developed, the US and the North America and the European countries and the Australasia. So, talking about the developed countries, if you look at from 0 to 4 to 85 plus, well, you don't live that long, as I see most of the graphs. Then you go to the next slide, population distribution comparison. So here you will see you may live longer in developed countries due to the reasons that we all know. And then the male-female ratio because females tend to live longer. Next one, population distribution comparison. Okay, I think someone is there. Right, now the ecological footprint, when I go to my next slide, but you are showing something back. So the ecological footprint is important because they have mentioned here about India is a culprit for 7%, but then America takes the pie as a average, not in the positions 25%, and European Union 19%, China 18%. If only they show the slide here, it would be more clear. And Japan is even better than India because they only have 5% of the total ecological footprint in million hectares, share of the global ecological capacity.
Yeah.
What it means is, like, we had the recent floods in Pakistan who admit that they are emitting 1% of the carbon emissions, but they had to bear the brunt in the form of in the kind of floods that they went through. 33 million people got affected and 2,000 that died. It's so sad. What is happening? The poor countries are facing the consequences of the global warming, and the reasons are the rich countries. This was discussed in COP27 also. So the ecological footprint for unsustainable living is very high, and the sustainable living is very low. By 2050, we may be facing more problems like 1.5 degree rise in temperature, and then there will be more crises. Can you go to the next slide, please? Okay, I am now on the page of toxicology here. As was discussed earlier, that this is something very close to my heart also, environmental toxicology, where the subjects to be dealt with are mostly epidemiology and pathology and pharmacology and statistics and physiology and chemistry. Because something very beautiful was just mentioned by the sheets sent by the organizers here. And I want to mention it because being a medical doctor, especially in the international non-government organizations and in the American field, Paracelsus, now in 1493 till 1541, was a reformer of medicine. He formulated the famous 4 pillars of medicine: the natural philosophy, astronomy, alchemy, and medicinal ethics. Alchemy was a means to refine the raw substances in order to separate the poisonous parts from the medically effective constituents. So he further used the alchemical terminology for the explanation of physiological and bodily processes. So according to Paracelsus, nutritional poisons are one of the major causes of the disease. Now, I emphasize again, nutritional poisons. And what we do? Nutrition. And so, are we taking poisons? So in his tract on the minor disease, for which he was actually very famous, he pointed out we still have disasters like in China and India in coal mines. So he gave the clinical pictures of the intoxications by the chemical compounds and other inorganic substances. So Paracelsus, and the famous saying, now this is an emphasis, all please say, all the things are poisons. I emphasize again, all the things are poisons. And that the degree of toxicity is only caused by the dose. So a dose of dome, which is alcohol, given in winter to kids, medicine. And when you drink in pubs, in clubs, especially by the so-called high society, it becomes otherwise. So you can just imagine how far thinking this man was 500 years ago. And we think we have progressed. They were people much smarter than us even 500 years ago. But the question is, what are we learning? Now, the population size dynamics, I just explained to you how many of us are coming into this world and how many of us are leaving this world. Okay, next slide, please. Okay, population distribution already explained to you, the developed and developing countries and the male and female ratio. Mostly people live longer, mostly like in, say, example, Japan, because of the lifestyle and the, of course, the reasons for being heavy to a country where these things are possible. So we learn about it. That doesn't mean that there are other countries as well. Population of millions. Okay, next slide, please. Ecological footprint also described as well. This is something to really ponder upon here. You see, United Nations is the culprit now, 25%. Yes, Am I correct? Yeah. Now the European Union, 19%. So where's the wealth now in these two countries, right? That's how we think. And even China, 18%. Yes. So India is only emitting 7% of it. So the first three, I imagine, are the culprits for such disaster and climate change in the world. So this is how COP27 was discussing and why the rich countries are profiteering. Something quite sad to talk about here. And again, the ecological footprint, as you can notice, the unsustainable living on Earth, which means it's not possible to live. And the sustainable living is a small footprint, which means it's only very small part of the world where we can live, and there's a large part of the world we can't live. Now, let's say the Delhi smog, the air pollution, which is becoming world famous. I was sad to see that on CNN that's the most polluted capital city of the world. Well, I love Delhi. I'm an Indian, and imagine, look, and that affects tourism, affects the people lungs, especially how the doctors over there are now perplexed by how to solve this problem. And things are getting from bad to worse. Okay, next slide, please. Um, Toxicology, what is the subject we were discussing. I want to go to the toxicology focus areas here. Something very important because we have regulatory toxicology, regulatory matters, forensic toxicology, the medico-legal issues, clinical toxicology, the manifestations of disease, environmental toxicology, the system effects, reproductive toxicology, reproductive effects, and the developmental toxicology, teratogens, etc. If you please move to the next slide, please.
Next, please.
Okay, I just mentioned the toxicology. We have the subjects here, the epidemiology, the pathology, the pharmacology, statistics, physiology, and chemistry. These all have to be encompassed. And here I must say something very beautiful of the two speakers who spoke before me. Dr. Nitin, I want to say hello to you, and you and RRC during the conference, sir. I enjoyed your talk, and Dr. Vasudevan, who talked so much extensively on rubber, because I come from Malaysia, and this was once the world's #1 rubber producing country in the 80s. So they call it the land of rubber. So I really enjoyed this talk because I live around rubber estates. Wonderful. Thank you. Next slide, please.
Next.
Okay, toxicology, again, the focus areas is regulatory, forensic, clinical, the environmental, reproductive, the developmental. Just explain to you. So we have the regulatory matters, the medico-legal, the manifestation of disease, the ecosystem effects, the reproductive effects, and the teratogens. Something interesting, a child born without limbs just occurred to me when I was working as a doctor in the hospital, and this is something very sad. If you go to Vietnam and if you've seen those bombs and wars between, say now, what, 50 years ago, the oxygen, the orange agent that was thrown by the Americans led to all these teratogenic effects. So that was developmental toxicology. So now effects of the chemical mixture are kindly focused on this. This is very, very interesting here. So if it is additive, right, effect is equal to the individual effects added together. Now we are talking of poisons and toxins here. 2 + 2 = 4. Everybody knows it, right? Now try to understand this. Synergistic. The combined effect of exposure to 2 or more chemicals is greater than the sum of their individual effects. Now look at that. 3 + 7 should be 10, but it's 80, which means 2 poisons can damage 8 times. Antagonistic. 2 chemicals, when administered together, interfere with each other's actions, or one interferes with the actions of the other. Example, calcium blocking tetracycline absorption, right? And we all know it. But antibiotic, 2 + 2 should be 4. It is 1. Look, it has gone down. Antagonistic. So potentiation, a non-toxic chemical causes a toxic chemical to become more toxic or more active. Example, adjuvants. So 0 + 2 should be 2, but it is equal to 7. Look at the research here. Isn't this wonderful that what damage is taking place? I may take some time even to digest this. Now, quality. Several agents that have no known toxic effects, that's what we think, interact to produce a toxic effect. 0 + 0 + 0 should be 0, but it is 8 times more lethal, as we see. So you can imagine what's happening in the world now and why all this is happening. All right, being doctor, I just thought we should share this. The mouth and the chronic disease in the smoking, it is still there in the world. We can have a lot of debate and argument. The other side does not agree with you. But it is damaging the environment, isn't it? Now, overeating, well, please, obesity is taking place. I'll have a picture of me running just to tell others that let's do something else. And poisons, come on, we have a lot of that in the world. Legal drugs, drug addiction is taking place in the poor and the rich alike. The medication, okay, let's talk about paracetamol, and it's come on, or a painkiller. But there's a lot of abuse, misuse, overdose. So the common title is what? The mouth. And why we put this as a heading? The mouth and the chronic disease. So diabetes and hepatitis and the cerebrovascular diseases and the cancer and obesity and all those things are now related. Why? Because it starts with the mouth. We can't control sugar, or we can't control overeating, or we can't control fat and oil and all those things. And poisons are going in through this portal. Okay, next please. Environmental and workplace agent exposure. Now, this is very interesting because we all have jobs, working places, and stay in homes, but we are being exposed to agents which are not very healthy. So, environmental and occupational engineering controls by the elimination, containment, and the substitution away. The public health and administrative controls. We have design and personal protective equipment, very popular in COVID-19 PPE suits, right? People did not know about before. And the containment system and the perimeter and the PPE penetration, the breach take place in agents, biological monitoring and surveillance. I'm just giving some ideas and some headlines only here. The first, second, and third prevention that typically is primary, secondary, and tertiary prevention, and the injury, illnesses, and the diseases following the acute and the chronic forms, all because of the exposure of the agent in the workplace, and that is the environment we live in today. Next one is even more interesting. Environment for carcinogens. See, developed countries, we are in the developed countries, right? So cigarette smoking, asbestos exposure, and high-fat diets. Well, we all know that. How many and how much have been all these fast food joints and to go in, especially even it hurts, even old, because it's easy to get. Also, very, very tasty, very popular, right? The blending lifestyle, I call it, but very questionable. Are we going to change our habits? Developing countries, again, the food preservatives, the viral infection, and COVID-19 is still in the air, dear friends, and the fungal toxins. All causing this chaos, and I will say the developed world is also facing the same problem because food preservatives, you just go to all these rich countries where cooking is probably getting out of fashion, honestly. Well, these people have work pressure and food can be bought from outside. They have machines, you just go to Japan and they have machines and you just have to put a coin and food comes out. So the hereditary factors and the pathogens, the viruses, the hepatitis B, C, you name it. Variants, Omicron, and maybe anyone around the corner. We don't know. Very good answers, honestly speaking. Oxidative damage to this also definitely carcinogens. What about the preservatives that we take, the food that we eat? Even the cooks and chefs in 5 stars, you know what they put to make the food tasty because you are there to have taste. You are paying a lot, but you're also paying through your stomach, as I call it now, through your nose. Factors affecting the environmental policy. Yes, next slide, please.
Next slide.
So thank you very much. Okay, very evident here, the economic, the cultural, the social, and the political, and this is the environmental policy, right? Based on all these 4 things, the economic, the cultural, the scientific, and the political. So politics is always. And so you understand what I'm trying to say here, that why environmental policies actually do not come to great success as they should. The reason is, again, these factors. Okay, next slide, please. the principles of environmental policy development. Now, that is something to think about if we have some policymakers sitting here. The guiding principles and philosophies may activate the formal and informal policy actors, the policy researchers and policy analysis in creating policies. The precautionary principle in environmental ethics, environmental sustainability, the editor pays the principle. You think the political pays a principle? Underline the word here. I should have put it in dark. Just to tell the world that if that was the case, then why rich countries gone free, poor countries pay the price? Something to think about. So the level of acceptable risk must be determined for hazards that potentially threaten the human and environmental health. Well, this is a formula. We will talk about that later. There's a lot of hard work done by a lot of people here. The next one, please. So the interplay between the evaluation process and the policy development. Okay, they put two in red now. Hypothesis to the policy. Now, what happens in between? The scientific evidence, the scientific data, environmental data, and the data. Synthesizing the model, risk assessment, and decision-making process. Only then a policy is made. So you just imagine how many flaws we have in a policy if these steps are not taken place. So politics, value, cost, ethics all come into play during the decision-making process, which leads to the policy, and all these have to be taken into consideration. Now, again, my questions are always very hard. Do they actually take place, or are they vested interests? So the policy cycle stages. Next one, please. Next slide. So there is an agenda setting. Wonderful. So there will be a policy establishment, there will be a policy implementation, there will be a policy establishment on the environmental objectives, and there will be policy definition, formulation, reformulation, if it is needed. Okay. Thank you. Next slide, please. Toxic Substances Control Act, which is called TSCA. This is US actually, enacted in 1976. So EPA authorized to require reporting, record keeping, and testing the requirements. People in this business will know these things better, and restrictions relating to the chemical substances and or the mixes. So the food, the pharmaceuticals, the cosmetics, and pesticides are not included, interestingly, right? And just to give you an idea, 80,000 chemicals are included. So you can just imagine how much chemicals are there in the world, and how much are ingested, and what are the side effects. Okay, next one is environmental impact assessment. Any change in the environment, whether adverse or beneficial, or partial reaction to the organization's activities, products, or services. So an EI statement may not be sufficient before it is produced. Well, in theory, it's wonderful. The whole idea is whether in practice all these things happen. So procedures for control of pollution should be, please look at the what should be feasible and cost effective, like in complexes with applications to prevent runoff into the ocean. And why do we see floods? Imagine the Tamil Nadu, okay, because you sit in India, and this was broadcast on TV in countries outside India. That's how we come to know. We have our own floods here, so there are now floods probably everywhere in the world. Watch at least TV sitting in your own house. And why is it taking place? Somewhere something has gone wrong. The architectural flaw, the drainage system flaw, the flaw is somewhere, and its flaw is very big. And it is getting worse by the day. So let's go further case studies, environmental policies to protect the human health. Because I do human health here. Next slide, please. The strategic plan and the Courts Act took it to place, the protection of the Arctic and the Antarctic environment. I'm talking of the world now. There was a policy reform in South Africa. There was a Water Act there. Environmental policies in economies in transition. The control of the pollution of the Kyoto. Very important decision made. Industrialization of China, protecting the rights of special and vulnerable populations, and the built environment. Okay, next slide, please. Considering the time limit, okay, the strategic plan that we have now is the reduction of the greenhouse gas emissions, the sustainable agriculture, the global climate change, the contaminants, food safety, including the program implemented by the Indian country, enforcement, compliance, measurement approach, the research strategies, directions and the targets, the environmental indicators, monitoring and related information. I'm going quickly, but the truth is something to really focus on during this climate change and crisis that we all have. It's about time to get it back together, and it's important for this plan, which is already 6 to 8 years old, is honestly speaking struggling because the pledges made by the rich countries, especially now in the COP27, doesn't seem to be fulfilled yet. Okay, next one is very wonderful, I think, because join something. Honestly, I will tell everybody, please, since there are a lot of people, number 138 now already, environmental advocacy groups. I am joining. So that's we call it Green Gate. And I just started documenting oil spill clearing done by the oil giant, disasters that are taking place due to the fossil fuels, and pledges not being entertained by the rich countries. So there's a National Resource Defense Council, there's a National Wildlife Federation, the Nature Conservancy, the Sierra Club, the Union of Concerned Scientists. There's a World Wildlife Fund, the WWF, very important. I have also joined that. Advocate, be an activist, play a part in this world, whoever you are, wherever you are, whatever you're doing, to make a difference in society. We can ultimately leave this world for the next generation. And the big question always is, what are we doing? What are we doing is the next slide, because I am doing something. So before I tell others, I do that myself. The next slide I am proud to show you, actually, because that's me in the front here. So this is the International Islamic University in Malaysia here, and I take students, and we are doing this candlelight vigils, a lot of awareness campaigns. So I'm wearing the Doctor US my own t-shirt. So this is getting people from 16 countries, students who come there, and so it's all up to you, because I'm the ambassador of youth, and I will put them into places so they carry this, become a snowball effect, and they do that in their own countries. It is just an awareness campaign as to, if you want to save the world, nobody's going to save it for you. You have to do it yourself and get the young out of the bad habits that they are now in, honestly speaking, as you can see around, to the good habits we can ask them to follow. And they will only follow us if we are examples of such things. So I make sure that I am an example. Okay, next slide, please. So because I'm an example, so this is me. So this is a small town I live in. This is called Ipoh. So this is 4 a.m. So if I can do it, I'm sure you can do it. So I am also ambassador. So what I will do, I'll get people out. So let the pollution be clean. Let us talk about environment. Let us talk about health. So things can be done, but you have to do it. And that is how this is one STM for 7 bridges, because we have 7 bridges. And so this one took place in the stadium, and I was doing 21 kilometers, a half marathon. All right, so nothing to be proud of. People can do better than me. The whole idea is do it. As Nike says, let's do it. It can be done. So thank you for showing this. Nothing so great about it. Next slide, please. So you can do it also, because I was a keynote speaker in this climate change. So you can be a doctor, you can be a humanitarian, but you can also make a difference in any field you touch. We call it the Midas touch, where you can turn anything to gold. The whole idea is I can sit here and still do things, and you know much better than me. And what the organizers are doing is, I would say, it's incredible. Word. So climate change, no one else is going to do. So what do we want? Next slide, please. This is what we want. What is our goal? We want greenery, right? This is paradise. This is why I'm here, because this place is paradise. Okay, wonderful. And this is what we want. Greenery is missing. Forestation is become what? Deforestation. Sad, isn't it? So where will the animals go? This is their home. Do not encroach on their home, right? We think about tame animals. All animals also need homes. This is their home. Do not go and break their homes. So please, plantation of trees. I noticed when I was in RRC, you do wonderful jobs. So I was supporting you in that campaign. So I'm very proud of you, and people are joining. So what you have started, even unconsciously, people who watch this, see this, they do make some amendments in their own lifestyles and in the areas and geographic areas where they live. Next slide, please. Another beautiful slide now. Don't you want clean, clear sky and some clean, more greenery? Look, it could be a photo from any part of the world, right? Imagine if this is your own backyard. Don't you want this? Are we not fighting for this? And it can take place, but we need to have a lot of the urban jungle removed away. Of course, there will be a lot of profiteering giants will come in, houses will be made. And taken away from you all. So again, the next slide. So I'm advocate. I fight youth. So the International Youth Center, 16 countries came there. I was leading village, and the whole idea is I fight for youth, I fight for the rights, I fight for human rights, so that people can take in the direction which we are supposed to take, and there has to be no profiteering and no selfishness. Because that is what money has not bought happiness, and we all know that. We think in the name of progress we are going high up. No, it is not. Environment has gone, and what else is left? You just tell me. Are you breathing fresh air? Is the same oxygen going all over the world? So with that, I would love to end here. I think there are a few thank yous. The secretary put a lot of thank yous here. Next slide, please. Let's go on. Okay, greetings from Malaysia to India and to everyone who's listening all over the world. Thank you, thank you, thank you. Next one, I think it's another thank you, I guess. Well, but I'm grateful for it. I want to show you my gratitude for all these opportunities. Ultimately, our world, we live in the same world. We could be different countries. Safe. Okay. Next slide, please. Okay, thank you with folded hands. Thank you again. Next slide, please. I don't know why it's Sunday. It's a Wednesday today. They may have Thank you. Next slide, please. Have a nice day, please. I want you all to smile. I want to thank my organizers, my beautiful organization, Dr. Mamta here, respectable sir. I met them personally, and I'm very happy that I've met them in my lifetime. I met some great humans on earth doing great work. Thanks to the organizing committee, Professor Dr. Hukum Singh ji, Professor Dr. Mamta Sharma ji, for all the time that you have been so nice, lovingly calling me all the time, and your team, your very big team. I see all your people there, and all your very wonderful people around, very honorable experts, academicians around the world. I congratulate you for your great work. So thank you. This one is nice one. Next one, I'm proud of this. Next slide, please. To the next one. Namaste, my dearest brothers and sisters, whoever is listening. I see the number 136 now online from RRC Alwar, Rajasthan. Oh, my favorite in this universe, I call it India. Love to come in. Oh, I'm very proud. Next photograph, it was taken by you. So that's why it is in my memory all my life. Next one, it's me getting in the, I think this is Pratap Auditorium in Alwar. This is probably Professor Aprinda Singh, if I'm not wrong. So love you all. Thank you again. God bless you. Keep on doing your good work. And congrats to the organizing committee. And hope to hear you again. Wish you all the best. Thank you. Goodbye. Love you all.
Thank you, Dr. Lekhi, and it was so nostalgic to see the last slides, you know. I was remembering when you were here, of course we were tense, being the organizers, we could not give much time. But it was so nostalgic to see those pictures.
Yes, I agree with you. Yes.
You are a family, you know, so it's very difficult to even thank you sometimes because ऐसा लगता है आप तो हमारे अपने हैं. So
बहुत खुशी होता है जब मैं आपको देखता हूँ और जब आपसे ये कनेक्शन बनता है कभी कभी जो मंथली हो गया अब तो इतना अच्छा लगता है. मैं तो कभी सोचता हूँ मैं ये देश क्यों पैदा हुआ. मैं तो वापस आना चाहता हूँ.
Exactly same here, Dr. Lekhi, and even Dr. Hukum Singh ji was asking me कि Dr. Lekhi बोलेंगे. मैंने कहा हाँ सर वो बिल्कुल बोलेंगे. He always remembered with a lot of fondness and a lot of affection.
जी आज मैंने देखा उनको बहुत अच्छा लगा. आंखों में आंसू आ जाते हैं. सच्ची बात है.
See you back in next July. Hopefully we'll be calling you again, troubling you.
जी
because एक और conference कर रहे हैं हम लोग offline. So
thank you
so much, Dr. Lekhi, for such an amazing lecture, and it's always a pleasure to hear you. And I would like to thank from everyone who is here, all the organizing committee and RRC community, all the delegates who joined your deliberation. Thank you so much. Thank
you.
So our next speaker is Dr. Ajay Kumar Gandhi. Dr. Gandhi is currently working as assistant professor in the Department of Chemistry and Government of Maharashtra, Government College of Arts and Science, Aurangabad. Dr. Dr. Gandhi, आपका बहुत-बहुत स्वागत, आपका अभिनंदन. His research interest include computational chemistry, computer-aided drug designing, application of e-chemistry in ecotoxicological evaluations. He has 6 research publications in journals of international repute, out of which 2 have been included by WHO in global literature on COVID-19. He has also presented many papers and poster presentations and as a keynote speaker in many national and international conferences. He has won many awards for the best presentation as well. Dr. Gandhi is a dedicated and hardworking teacher who is admired by the students. Even Dr. Gandhi, you are being admired by the delegates. You speak very well. After starting, please go ahead with your delegates, Dr. Gandhi.
Thank you. Thank you once again, Professor Mamta ma'am. And is my sharing started?
Your slides, no, not yet.
Actually, I opted for sharing. So it's actually is there.
Yeah, we can see you, but not the slides.
Just a minute. I'm using new device, so maybe some issue. Start recording. Okay.
Yes, now we can see your presentation.
Okay, so slides are now. You can see slides, ma'am, no?
Now they are gone again. They were visible. Why two of me are coming? Sheetal?
Hello. Hello.
Now? Now?
Now, yes, sir.
Slides are visible, no, madam?
Yes, your slides are visible.
Yes, thank you. So let me start with my presentation. Thank you, Mamta ma'am, once again for inviting me on this auspicious occasion. Okay, now I'm on slide presentation mode. So thank you for inviting me on International Short-Term Training Program, 5th, of the production of and regulation of chemicals and toxins for environmental conservation. I'm going to talk today on the topic related to ecosystem, the conservation of ecosystem through computer-aided production and regulation of chemicals and toxins. Am I audible, madam? Because there are some disturbances.
Yes, you are very much audible. Sheetal, यहाँ से mic off.
Yes, yes. If you can ask other people to mute their audios, no, so I will feel much comfortable.
Everyone from here except you.
Okay, thank you. So, ecotoxicology or ecotoxicity, that much familiar with the terminology, but it basically correlate toxicological studies in for the ecological aspects in the biosphere. And here in ecotoxicology, we deal with some effects of materials, toxic effects of material on biological system like organisms and other creatures in the same ecosystem. So the very basic question that pop up in mind is what some chemical make it toxic, and why some chemicals are toxic and some are not. So the basic idea is that everything which is in place at a right time, in a right amount is good or boon for that particular immediate environment. But what makes it toxic is that whatever if it is not in a place, like what is the intended place for that particular chemical, and if it is not there and somewhere else, then that compound can be a toxic compound. If something is intended to cure something in a particular concentration, and if it is in excess of that concentration, that can be a toxic thing. So anything in excess is also a toxic thing. Something which is intended to have action for a limited period of time, but somehow because of some reason, if it is delaying its stay there, having deposited there only, then that also is something toxic, unless and until that compound cannot be called as a toxic. So that is another reason that something which delay its stay there, that is toxic for that particular immediate environment. And of course, if you mishandle something, like you take it in excess, the proper concentration and SOPs, we know the term much in use, that standard operating procedure, if you are not following that for that particular chemical compound, that is also a toxic thing. Otherwise, if you handled very carefully, that will not be a toxic thing. So these are the aspects that we already know about. Then next is, so things, this makes clear here that things by themselves are not toxic, but we human being or the user or applicant of that particular thing make them so. So that is the idea behind toxicity. Then what, when we say something is toxic to the bioenvironment or biology or bio system, biosphere, then in what term we are calling them toxic? That they are cytotoxic. They can kill directly those organisms and cells by killing their cellular structure or tissue structure, or they can do so by just stopping the functioning of some biomolecules like DNA, enzymes, proteins, and hormones, which are very vital for that particular enzyme to function properly, or that bio creature properly. Where that can be evident, from what that is evident that whether a given compound is toxic, then in having that compound there with that creature, that make it featherless, furless, scalesless. So that is in case of the fishes and other some aquatic animals. There may be the evidences of failure, vital organ failure. That can be a toxicity of that compound that is evident from that particular thing. Then destruction of natural food. Some chemicals not directly harm that particular creature, but on what thing they survive, that particular bio thing they destruct, and by that way they become toxic to that particular creature. So may not be directly, but indirectly also certain compounds, certain chemicals can be responsible for the extinction of some species. So that's the another toxicity, indirect toxicity way. And the very harsh thing with this toxicity is that it do not get stopped at particular species. It is having tendency to propagate through species. So incoming generations are also getting infected or affected with the toxicity, and that really makes this situation very bad for some creatures. This is picture that I have shown many times to we people in the presentation, because this picture is really a very heart-wrenching picture. You can see the animal helplessly fallen into a lake, and it is surrounded by so many dirty things, and you can see his or her skin also pigmented, and that is a clear indication of some toxic thing happened with that particular creature. And you can see there are very less number of scars on that. Feathers are also removed from that particular creature. So that is the thing that really reach anyone's heart. This is actually called as an ecological crisis. In many species, aquatic flora and fauna also, this is evident. Feature of many such a species is this, and you never know that this can be the feature of Homo sapiens species also. So really alarming situation for all of us, and we have to take necessary action to deal with this particular crisis. So what causes this? That there are many causes that are human interferences are there, like unwanted use of fertilizers and many other chemicals, insecticides, the uncontrolled use of that particular thing, and without any proper care, they are poured in the environment back. So that can be also a reason. So these are some reasons by which our environment get polluted. Many chemicals are marked as hazardous chemicals by various organizations which are globally accepted and working day in and day out in this particular aspect, like Organization for Economic Cooperation and Development. They mark certain chemicals potentially hazardous for our environment, and we must stop using them as early as, immediately we have to take that necessary step. Then just slide come out, slide move. Just a minute, there is slides are not moving. Okay, sorry. Then pharmaceuticals, agrochemicals, pesticides, herbicides, and some cosmetics also. We are using cosmetics to look ourselves great, but in the last slide we have seen one picture how ugly that bird become because of the cosmetics that we used in past. Then that I mentioned, the uncontrolled use of things like pesticides, insecticides. And one term I would like to coin here, that we are literate, but we are not ecologically literate. We are ecologically illiterate, environmentally illiterate. We don't know what to use, where to use, in what proportion must be used, and what must be stopped or forbidden for use by the society. So that is the thing, that ecological illiteracy is a big issue really, and we really need to work on that. So who is culprit? In my opinion, there is no a single person or single part of the society is responsible for this ecological crisis, but everyone is responsible, maybe directly or indirectly, maybe in a more proportion or less proportion. Maybe we were responsible in the past, maybe presently we are responsible, and in the future also we are going to be responsible for all this crisis happening around us. So I would say that everyone need to take necessary action against this. Unless and until we take necessary action against this, there is really a huge problem in front of us, and that will really go our species extinct. So there is a time. This is the time to take action on really. So as a chemist, like the topic also now much on in the field of chemistry. This training program title itself is on the side of chemistry people. So we chemists, we always deals with solutions, and not only these solutions which we see in beakers and conical flask, but we come up with many solutions which can make our globe again green. And when I say green, then I mean to say that every creature, every species that is flourishing to its fullest potential. So experimental ecotoxicological evaluation against numerous endpoints, that really challenging situation for the chemist. That there are many chemicals out there in the environment, and daily many chemicals are getting introduced to the environment. So it's really hard and really difficult and really impractical to check every pollutant, and not all the pollutants are toxic directly. They take years to come into picture with their toxicity. So that is another level of challenge in front of chemists. It is a cost-effective and time-effective procedure. Actually, it takes a large amount of money to be invested for having control and check on all the chemicals around us. We have to test them against all the available bio things around us, all the biomolecules even, and then we come to we reach to certain conclusions where we get that where we come to know that which is the actual species which is really terrifically harming the creature, and at what point. So that is really a cost and time inefficient process that chemists usually follow, and it is impractical also. Like we cannot take every creature and every biomolecule in it and test it against the molecule and then gather the information and take some conclusions out there. So that is the case there. And some unattainable are also, like we cannot reach to we cannot reach to every species, and we cannot check every species. So that is also unattainable. Like Einstein once said that we cannot solve our problems with the same level of thinking that we created them with. So really the thinking process that so far we have developed or chemists developed actually created that problem, and that the same thinking line we cannot have as a solution also. So our purpose is to find some innovative ideas which can charge our globe back to its green state. So thinking green is the need of our now, And for the sustainable development, it is the only way out, I would say, to charge our globe back to its full potential grown state. So green solution, when I say a balanced ecosystem that we want to charge back to its natural state, that the balanced ecosystem means every life creature, maybe floral stage or fauna stage it is, maybe in a clean water or marine water, fresh water. So all the species that are found around us must flourish into the full of their potential. That is the intent of our work in this particular field. So that way we have to think, then only we can come with the proper approach. One of the approach that I used in my long 4 years of my research is the computer assistance to deal with all these problems that we have, that chemists usually follow. So the computer assistance is really going to be a time efficient and cost efficient process that we can deploy. There are many computer assisted approaches that are in use, like Toxico4 modeling is there. Some quantitative structure toxicity relationship is there, where we can deploy which virtual screening technique. Then molecular docking and molecular dynamic simulation, which in conjunction with this QSTR process or Toxico4 modeling process, we can assist further computer assisted drug designing in giving a reliable and robust results there. Then artificial intelligence and machine learning is also nowadays picking up, and they are really making this computer assistance much far-reaching and comprising a large number of data sets we can evaluate there, and we become more and more, we are widening our approaches more and more better way. So ecotoxicological evaluations and prior prediction of ecotoxic chemical can really stop molecules at the first place only being getting introduced into environment. So having this computer assistance, we can stop molecules from even from their synthesis also. That level we can do things with the computer assistance. Then this largely cut on the expenditure on the synthesis and subsequent biotesting also. I mean, with this computer assisted drug designing, we can cut on the synthesis of molecule itself. Why to synthesize certain chemical if it is going to show a harmful impact on certain biomolecule, they are going to deactivate it or going to be toxic to the environment. So at first place, we are cutting the cost of even synthesis itself. And even though if we are synthesizing certain molecules in biotesting, we are cutting another number of molecules from the biotesting. So there are multiple layers where we can go on screening the molecules, and at the end we left with only a certain bunch of certain number of molecules. That bunch of molecule only need to be synthesized and tested. That will to some 1,000 and 10,000% 10,000 times that will reduce the cost of that particular synthesis and biotesting. And one more thing, that this computer assistant promote or really come to the help for or rescue of the animal sacrifices in the laboratory, that the usual processes. For a human sake, these animals are being sacrificed in the laboratory, but computer assistance cut on that aspect also. So earlier, this is something that really can fetch the attention of and fetch the love of animal lovers as well. So that's the thing. Single computer with the sophisticated technique can cut completely on the animal sacrifices in the laboratory. So that's the added advantage. Then this the particular aspect that today I would like to highlight more on is the quantitative structure toxicity relationship. In this, it's actually a multidisciplinary technique. Here, statistics, mathematics, computer science, chemistry, botany, all the disciplines out there or basic sciences out there can be deployed, and with the help of every subject from the science discipline, we can deploy it, and we can have a robust technique out there for the for this particular study, QSTR study. This is not just a mere imagination of researcher, but it actually shown its usefulness and applicability, that it is approved and recommended by various globally acknowledged associations, like OECD association is there, and many environment protection agencies also approved this technique, and they have in their standard operating procedure introduced this particular technique to be followed, and is as the mandatory technique before synthesizing certain chemicals, before writing their researches and using them for further biotestings. So that well advanced technique and flourishing technique is now that QSTR is. And in QSTR, what we do, we develop a model where just having it's just like a mathematical formula. You put all the value that you know and that you calculated, and get the result whether to use this particular compound, whether this compound going to be toxic or not. That simple way I can make that simple statement I can make here for QSTR technique. And it is not just a technique that like you have given with one formula and now your work is done now. That's not the case. Actually, the applicability of this particular equation is very straightforward, but behind that there are many things that work. Like, this is not the equation just thrown at the thrown at you, but it is actually validated at multiple levels for its reliability, for its robustness, for its external as well as internal predictivity also. Like, this is not the equation just given to you, but already it is tested for its reliability. So that is the advantage of this technique, and that too we are not doing with the bio things. We are doing that again with the computer system. So everything from point A to point D, we are using computers for the things. And not only we are that every equation is not applicable for every aspect of this bio thing or QSTR. There are certain types of chemicals only those chemicals can be tested with this particular equation. So we define we not only give you equation, but we give you the domain also where that exactly equation can be used, and this will save really researchers from misleading results and synthetic organic chemists from misleading results. Like, if this particular compound is not falling in the domain of the applicability of this particular equation, then you have to search for other equation, you have to build another equation that will help you in this particular way. So that is the case. Then okay, what are the different steps? Steps also here are well-defined steps that we follow in QSTR modeling. First step is collection of data. Here we collect both biological and chemical data. We gather the information of various target that are possible target for the given compound to be toxic or not to be toxic, and we gather some chemical information also, like we gather exact structure and proper orientation of that particular chemical compound. So both things we calculate in the data. Then we calculate various descriptors. So what do you mean by descriptor? Descriptors are the chemical features which are expressed in terms of numbers. We are not saying only that there is hydroxyl, but we are talking in terms of number, that whether there is zero number of hydroxyl groups, or there is one, or there are two, or there are three, this way. So whatever the chemical description that can be seen or that is associated with the molecular chemical entity, we try to express it in terms of numbers, and we give it in the molecular descriptor form. And there are various softwares now are there which can almost 60,000 and more molecular descriptor for a single molecule. Now we can calculate unique descriptors, we can calculate. And such a large data set if you have, we need a really strong computing things that will help you to process on that data. Then all this information, biological and chemical data set with this molecular descriptor, they are subjected to the objective feature selection, where only relevant information or which is approved by statistical analysis, only that information is retained, and the further information is then subjected for the future subjective feature selection and QSR model development. So at every step we are reducing data to the level which is the relevant only, and we are not wasting our energy and computational power in in studying that the data set which is not relevant. So that is the advantage of this, that at every point we are providing such a scrutiny to the data set which will fetch you at the end or as an outcome a little amount of information which is very exact, to the point, and very relevant. So that they get, and once you get this QSTR equation or the model, and then you at the end subject it to the validation purpose, like internal validation, external validation. And one more thing I would like to tell, that as we are deploying all the statistical techniques and data available there, data itself, before submitting it to various softwares, that data itself checked for its robustness. So that is the advantage. Like, it is not the case that we are providing such a data which is itself a garbage, then we expect a garbage out thing. So garbage in and garbage out, that particular thing is only at the first place only we have taken care of that step, that we are not providing certain garbage data to that particular software, and that avoid us from getting a unnecessary unuseful or misleading information giving QSTR models. So that is the added advantage of that. And then at the end, as I told in the last step, that we are not only providing equations, but we are giving its applicability domain also. That will really save us from applying or deploying this particular equation at any random molecule. No, you are given it the information where this equation is applicable and where you should not apply that particular model. Then in the data collection, we collect data things like we take its we try to find out its name, exact structures, and we convert that particular structure into a readable, computer readable language that is called as SMILES notation, SMILES. That is that are entries that are readable by computers, and then we convert them into their 2D and 3D structures to get more and more chemical features of that particular molecule. Then we remove that particular data remove that data and make it free from any salt and charges. So all the neutral stage molecules that we start working with, and then we subject them to geometrical optimization. Geometrical optimization where all the molecules are taken to the level where they actually can exist. That is the minimum energy structure for that particular molecule. Then in biological data, we try to get information like its LD50 value or IC50 value. These are the values. I mean, if you are, for example, if you are talking about IC50 value, that means it is the 50%. It is the concentration of particular compound or chemical that is needed for 50% of its deactivation, or 50% deactivation of certain biological molecule. So that is the value of the IC50 value. That is the significance of IC50 value. And then we try to take a biological data where uniform bioassay used for the purpose. Then in the molecular descriptor calculation, we try to find out as much large information as we can, like number of hydrogen bonds, what are the different types of carbon with the atomic number, at what point carbonyl group is, how many number of rings are there, whether they are aromatic or alicyclic or acyclic. This is so more the information, better it will be. So nowadays softwares are getting developed in a way that more and more amount of relevant information we are trying to calculate, that too with the help of computers. Then many free and open source softwares are available free of cost there, and they are also available. We can use them online, we can download the files, and we can use them offline also. So open and free software is really a advantage, because you did not, I mean, the infrastructure is not something that is stopping you from this particular research. There are many softwares available, and anyone can use those softwares with their own capacity. So that is the advantage of this technique, that it is not limited to certain institutes where the infrastructure is available. Anyone can start working in this aspect. For example, PyDescriptor is there, which can calculate more than 45,000 molecular descriptors alone, Paddle, and there are some Codesa Pro like softwares are also there, which can calculate quantum mechanical quantum mechanical molecular descriptors that take care of three-dimensional things about the molecule. Then data pruning is something where you just in the last but one slide I explained that you remove out unnecessary information. That is the data pruning, that is called as OFS, objective feature selection. Then we subject it to subjective feature selection, SFS, and QSTAR modeling, where we split data. For example, if you have 100 molecules, we split them into 80-20. 80 molecules only used for the development of the model, and 20 molecules are kept aside. They are never shown to any software, anything. They are as good as newly synthesized molecules. So data splitting is the important step here, and then we regress the given information against the bioactivity. Like there are many chemical features expressed in terms of number. We regress them against the IC50 value, for example here. So we get the equation in a linear form also, maybe in a non-linear form also, or there are other statistical mathematical techniques out there. We can use that also. So we just wanted to get what is the relation between the molecular features expressed in terms of their number and activity. Having hydrogen bond there is helping that particular molecule to inactivate it or activate it. That is the thing that we try to express in terms of numbers or in terms of equation. So regression technique is one thing that statistical contribution we can say is important, because that is the thing that we have to take decision on whether I would like the particular research we would like to take on the line of linear or non-linear or various other techniques like hyperbolic equations are there, where just you need to get one equation where you can correlate certain thing against certain another thing. Then there are some naturally inspired programs also, like genetic algorithms, neural networks, random forests. These are the techniques which are used in subjective feature selection. So this is the advantage that we can have the variety of programs out there that we can use, and we can have that flexibility. If certain data set is not working properly with the genetic algorithms, we can easily switch to neural networks things, and so on with the random forest things, or KNN, you might have heard about this. So this is the case. Then reliability, robustness, and predictiveness is something that we check the generated data set, where data fitting parameters are checked, like we calculate its R-square value, mean variation values, and we subject it to internal validation also. Internal validation means whatever the equation that we have developed or got developed, whether it is applicable back to its original molecules from which this model was developed, that is checked in internal validation. And in external validation, we now those 20 molecules which we kept aside in the first step, that we can use to check whether these 20 molecules getting predicted for their IC50 value, which we already know with this equation also, and with what deviation we can calculate, with what precision or accuracy we can, and on that basis we can get assured that okay, this particular model can be used for the prediction of the future molecules as well. And then applicability domain, with the help many graphical techniques are used here, like leverage approach, that is very well used in graph things, mathematics or statistical things, that this leverage effect is deployed in Williams plot technique, and that Williams plot we can use for this analysis of applicability domain. So advantage is that it's not just a bulk of information in some numbers, but we can have the representation of results and things in forms of graphs also, which are very easy to understand. Then at the end, I would say all these techniques already chemists usually do in the laboratory with chemicals and other apparatus, but as advancements in computers are taking place or have taken place, with that we started outside the laboratory in the computer labs also. So whatever we are going to do in the laboratory with the chemicals, same things we can perform, the simulations and things we can perform with the help of computers, and much reliable, robust and precise results we can get in using computers also. And nowadays the things that computers can function better and better and more better with the help of large data sets. So as we have more data with us, we can get more reliable results, and we can widen the horizons of our applications of this particular thing. And to that rescue, or to, or you can say that the extension of this computer thing is that we are taking the assistance of artificial intelligence and machine learning also to cover large data sets. Like usually we people with the normal computational power, we can work with say 100 and 1000 molecules only. But if you are having at our disposal lakhs and crore molecules, then it is artificial intelligence and machine learning that can be deployed to cut on the time and cost further. I have one example to give you, that in China recently, I mean not recently, in last the 2 years back, China, with the help of artificial intelligence and machine learning, introduced a single drug in just 45 days. And otherwise that thing have to had known to take 15 to 20 years on an average. And biotesting is another thing, and it's $1 million affair. But with the help of this computational power and artificial intelligence and machine learning, China proved that we can cut on the time and cost. So that is the advantage or future of this particular QSTR study. So thank you so much for giving me opportunity to share my thoughts. I'm really very sorry for this background noise, because right now I am in the college and lectures and things are happening around. So thank you so much. If you have any doubt, question, these are my contact details. You can write to me, you can ask now also. And I would another thing that I would like to announce here, that I'm working in this particular field since 4 to 5 years, and now I'm ready to collaborate on this particular aspect. If any of the participant or other dignitaries out there, if you have any idea that can be correlated or can be assisted with the computer things, I'll be happy to collaborate you or assist you in that particular aspect. So thank you so much for all the time and opportunity. I would like to stop my presentation here. So if you have any question, please let me know. I'll be happy to answer.
Hello. Can you hear me? Hello. You are done, Dr. Gandhi?
Yes. I done with presentation. Let me stop sharing now.
Beautiful slides, Dr. Gandhi. You need to give us, one day a lecture on this and how to make the slides which I show in the IST.
Me also learning how to make presentations better. So I will really learn and would like to share my knowledge how to create nice slides. I'm also learning, madam.
Practical things, like everyone face them. No one want to talk about it, but these are the things we all face as academicians, right?
Yes, as we go into this, much better we become in this. So that's my idea. But I will really, I would like to really collaborate on that aspect also.
Thank you. Thank you so much, Dr. Gandhi. That was such wonderful presentation. You can see the chat box. So much for you. Very nice, productive session. And so much for you. I know you are a wonderful speaker and a very hard-working person. Thank you so much for coming with us and joining this mission for the environmental conservation. You know what? We all can do these things only because you all are there. Thank you so much. आपका बहुत धन्यवाद समय देने के लिए. And with this, we come to the end of the first day of isstp-5. I would like to extend my heartfelt thanks to all the speakers who are very learned and knowledgeable scientists of their field, and they have spent valuable time to be with us here in this training program. I would like to tell all the speakers that we, the organizers, and all the participants are very happy and delighted to have you here with us. And I hope you also had a wonderful time, like we had with you. Thank you so much, all the delegates, for giving your time. And till now, we are more than 100 together from different countries. Thank you so much. About the feedback form, as we did before, we will have only one single feedback form, which will be circulated in the valedictory session. There will not be any other feedback form, one single feedback form, and that will be circulated in the valedictory session in the chat box of the Google Meet. Now, this is Dr. Mamta Sharma, Organizing Secretary of the isstp-5, along with my team, Sheetal, and my another computer operator. What is his name? Rishi Sharma, and Dilip, and my patron and principal, and all the people who are present here, Dr. Upendra Singh, Dr. Sanjay Dargan, Dr. Sudha Sukwal, Dr. C.D. Veena. We are signing off from the campus of Rajrishi College, Alwar. I will see you all tomorrow at sharp 11:15 a.m. See you. Bye-bye. You are a wonderful people, and have a wonderful day ahead. Bye-bye, and see you all.
Stop it.